everyone, welcome to our C++ full course by Simplilearn. C++ isn't just a programming language, it's the backbone of software that powers operating system, game engines, high-performance app, and even finance algorithms. If you want speed, control, and versatility in your code, C++ is where it all begins. In this course, we will take you from the fundamentals of variables, loop, and functions to advanced concepts like object-oriented programming, memory management, and STL. You'll get hands-on practice writing efficient, optimized code that can handle real-world challenges. C++ skills are highly sought after in software development, gaming, embedded system, and competitive programming. And by the end of this course, you won't just write C++ code. You will be building robust, high-performance applications that stand out. So if you're ready to geek out on coding, master the power of C++, and become the developer every team wants on board, hit that like, subscribe, and let's dive into the world of C++ together. Also, if you're interested in growing your career in full-stack development, then this AI-powered full-stack development program is a great way to start. This is a 9-month live online interactive program with comprehensive learning, hands-on experience with top tools that leverage AI to enhance your outcomes from development to AI-powered testing. This AI-powered full-stack development program is designed for professionals aiming to build and optimize modern web applications and develop interactive websites with React, HTML, Tailwind, CSS, and JavaScript. And the greatest asset of this program is at the end of this course, you will be honored with a course completion certificate from both Simplilearn and in collaboration with Microsoft. The core advantage of this program is you get industry-relevant skills in front-end, back-end, version control, containerization, and a lot more. So guys, what are you waiting for? Hurry up and enroll, and you can find the course link below.
And welcome to this video where we'll be telling you how you can install C++ on VS Code and Dev C++. After we are done with the installation, we'll also learn how to run a program on both of these code editors. So we'll start with Visual Studio Code. To download VS Code, let's go to Google and search for Visual Studio Code or VS Code. We'll click on this first link. This is the official web page for downloading the Visual Studio Code. And we'll now click on this download for Windows blue button. And now we'll click on download now. Here it is getting download, and as you can see, thanks for downloading Visual Studio Code for Windows. Once we are done with the download, we can click on this open folder. Here it is. Now we need to install this file, so we'll double click on this file. And this is the setup wizard. We'll click on this I accept the agreement. And we'll click on next. As we have accepted the license agreement, now we can select our destination folder or we can leave it as it is. But make sure there must be 293.2 MB of free space on that particular disk space. Now we'll click on next. Here we can again click on next. There is no need to change over here. And now you can click on this create a desktop icon button or anyone else as per your choice. Now we'll click on next. And now we'll click finally on install. It is getting installed. It will take some time. Now we can click on this finish button. Launch Visual Studio, we have marked it. It is already marked. So when we click on this finish button, it will launch the Visual Studio Code. So as we can see, this is the Visual Studio Code. So as we have installed VS Code, now we have to configure it so that the C++ programs can run in this code editor. So in order to do that, we need to add some extensions. So we'll click on this extensions button. Now here we will write code runner extension. We'll write code runner, and this is the extension. We'll click on this install, and it is getting installed. Here are some instructions. We can click on Ctrl plus Alt plus N, or press F1 and then select type run code, but we'll deal with that later. Now we'll add another extension, that is C/C++. Here it is. We'll click on this install. Here we can see downloading Visual Studio Windows Debugger. It is getting installed, and I think it is installed now. So as we have added both the extensions, so let's move on and do a program of C++ in this code editor. Okay, so first of all, we'll create a new file. We'll go to File and click on this New File. Now in order to save this one, we can click on Ctrl S, or we can go over here and click on this Save As. Now we can select the location, like let's keep it over here only. Let's name it as visual.cpp. .cpp is the extension which is used when we want to do a program in C++. Now we'll click on this Save button. Now let's do a simple program to check whether the program is running on this code editor or not. So we'll include the header files, #include iostream. Now we'll write namespace standard. Now we'll write int main. Now inside int main we'll display a message, welcome to this video. Okay, now return 0. Make sure to save this after making changes, or you can click on Ctrl S, or you can go to File and click on this Save. So once you have saved the program, now you can run it. We can click on this play button. It will run the code. As we can see in the output, welcome to this video, we can see. Here it is. So it means our program is working. It is running fine. Now let's do another example in which we will take the inputs from the user. So let's make a new file. We'll go to File and click on this new file. Now we'll save as, and we'll write visual2.cpp. Alright, in this program we'll take the input from the user. So start with header files, #include iostream. Our spelling is wrong. #include iostream, after that using namespace standard. Now inside int main, we'll take the inputs from the user. We'll display the message, enter the first number. Now using cin, we'll take the input. We forgot to mention this, declare this n1 variable. So we'll write int n1, int n2, and int sum equals 0. Alright, here we have taken the input of n1, the first number. Now we'll take the input of another number by displaying the message enter the second number. We'll write N2. Now we'll add both of these, N1 plus N2, and we'll display the result. We'll write end line so that it looks good. Alright, now we need to save it. We'll go to file. I'll click on this save. Now it is saved. Now we can run this program. We'll click on this run code. Now in order to write the first number over here, that is, in order to write in the terminal, we have to configure the Visual Studio Code. And to do that, we'll go to file and we'll now go to preference, and in the settings we'll click on the settings, and here we will type run in terminal. Alright, now we can scroll down and here we can see code runner run in terminal. In my VS Studio it is already marked, but you have to mark this if you want to write in terminal or enter the inputs in the terminal. Alright, once you have marked this, you can close it and then you can Control S, that is save, and then you can close the VS Studio and then open it again. Once you are done, now let's try to run this. So now you will be able to write the inputs, like let's say 4. The first number is 4. Now the second number, let's say 9. On addition it becomes 13, which is the right answer. So these were some configurations that you need to do if you want to run a program of C++ in Visual Studio Code. So as we have understood how to download and configure Visual Studio Code for C++ programs, so let's move on to learn how we can download dev C++ and run C++ programs in that. So let's go to Google and type dev C++. This is the first link. We'll click on that. Now this is the green button saying download. We'll click on that to download dev C++. As you can see, it is getting downloaded. Your download will start shortly. So now we'll click on download now. Now it is getting downloaded. It will take a while. The size of this file is 48.1 MB. So as you can see, the downloading is almost done. So the downloading is complete. Now we'll click on open folder. Here it is, dev C++ setup. Now we'll click on this setup. We'll click on yes. The setup is loading. So now here we will select the preferred language. It is English. We'll click on OK. Now we'll click on, this is the license agreement. We'll click on I agree. Now we'll click on next. We don't need to change this, I think. The space required is 346.8 MB, and we'll click on next. Now if you want to change the destination folder, you can, but I don't want to change it, so I'll click on install. Now it is getting installed. It will take a while. It's done, and now we'll click on finish, and it is marked. So when we click on finish, it will launch the dev C++. So here we have to select the language. It is English, so we'll click on next. Here again we'll click on next, and now we'll click on OK. So this is our code editor, that is dev C++. So let's write a code. First of all, let's create a file. We'll go to file and go to new, and we'll click on source file. Alright, now we need to save this one, and in order to save this, we'll click on file, then we'll go to save as, and now we'll select the destination and name it as dev.cpp. Alright, now let's start with the header file, hash include iostream. We'll do a simple program over here using namespace std, because we want to check that whether the program is running in this editor or not. Namespace std. Now we'll write int main. Inside int main we'll display a message, welcome to dev C++. Alright, after that we'll write return 0. Now let's try to run this, and in order to run this program we'll go to execute, and now we'll click on compile and run. Here this is the pop-up, welcome to dev C++. As we can see, this is the output. Now press any key to continue, it will close this window. So our output is correct, welcome to dev C++. So this is how you can run a program in dev C++, and our program was also working fine in the Visual Studio Code. So this is how you can download both of these code editors to run the C++ programs. Let's start with the introduction to C++ programming. C++ is a popular programming language introduced by John Strostrup in the year 1979. The aim was to make a dynamic language that is efficient and has some additional features to C. Initially, it was called C with classes as it was an extension to C language, but later renamed as C++. It is general purpose case sensitive language, and it is called precompiled language because it converts the source code directly to the machine understandable code. It is an intermediate level language because it contains both features of high level and low level language. C++ supports the features of object-oriented language like encapsulation, inheritance, polymorphism, etc. It also supports procedural programming and functional programming as well. Now, as we have understood about C++ programming, let's move on to our first program in C++. So the first program for beginners is Hello World program. In this program, Hello World is printed. It is very basic program, and in the first part of the program we are including a header file hash include iostream. Header files are generally used to import features into the program. Functions like cin, which is used to take the input from the user, and cout, which is used to display the output, are defined in this iostream header file. Here using namespace standard means we are using all the things which are within the standard library. The second part of the program is main function. This is a special function from where the execution of program starts. Inside the main function, we are printing hello world using the cout, which is used to print the output. Return 0 on the next line will indicate the program that nothing will return and program executed successfully. So let's try this Hello World program on our code editor, that is VS Code. So let's first of all name the file hello.cpp. So first of all we'll include the header files, #include iostream, and then namespace standard we'll write using namespace std. Now we'll write the main function, that is int main. Now inside this function we'll print using cout and we'll write hello world. After that we'll write return 0. Alright, now let's try to run this. As we can see, hello world is getting printed over here. So this is how it's done. So now let's move to our next topic, that is types and variables. Coming to types and variables. In C++, there are different types of data type that acts as a keyword, which is responsible to define a variable. First is Boolean data type. This keyword is used when we have two values, either true or false, and these values are used when there are conditions. For example, if the condition is satisfied, then it's true, otherwise it will return false. Next is character data type. This character data type is used when we are dealing with alphabets and symbols, and it is used to hold a single character within the variable. Integer data type. This data type is used for integer values. They can be both positive and negative. Next is float data type. Float is used when we want to store values that are in decimal form. Now, variables. Variables are used with these data types. It is generally used to store values. And this is the syntax to define a variable. First, we will mention the data type and then the variable name of our choice. For example, int is the data type and data is the variable name. Moving to arrays. Arrays are one of the most important and widely used concepts in C++. It can be defined as a collection of similar kind of elements. The elements of array are stored in contiguous memory locations, that is, one after the other. Arrays make it possible to store multiple values of the same data type into a single variable. The syntax to declare an array is first we will mention the data type, then the array name, and after that number of elements inside the brackets. Our next topic is strings. We can define strings as a collection or group of characters. It is basically used to represent text in the program, and we can perform many operations on strings in order to manipulate it. The syntax of string contains a collection of characters surrounded by double quotes. For example, here string is the type, str is the name of the string, and coffee is the value that is assigned to the string. In C++, there are two ways to create a string. First is C-style strings. In C-style strings, collection of characters are stored in the form of arrays. They are basically arrays of type character. The second way is using string objects. We can create string object to hold a string. They are implemented in the standard library, which we must include in the program using #include. Next is if-else statements. If-else are two conditional statements that are generally used when we want to run the code based on some conditions. We run a block of code which is inside if statement only if the condition is true. For example, if the number variable here is equal to 10, then only the block of code will execute and will print the message you got it. Otherwise, it will run the else block and display the message written inside that block, which is not this one. Now coming to loops. First is for loop. For loop is the repetition control structure that allows us to repeat a block of code for a fixed number of times, instead of repeating the same code again and again. The syntax of for loop has three parts. First is initialization. It is used to initialize the loop. Next is condition, which is used to determine when to end the loop. And last is updation, which is used to update the loop variables. For example, inside the loop I equal to 0 means we have initialized the loop from 0, and I less than 10 means the loop will keep on repeating until I becomes less than 10. That is, it will repeat for 10 times in total from 0 to 9, and I++ denotes that we are incrementing the loop after each iteration by 1. Another type of loop is while loop. While loop are used in C++ when we don't know the exact number of times the loop should repeat. It repeats the statements till the given condition is true. The syntax of while loop is while keyword and condition in the brackets, and the loop will iterate till that condition is true. And once the condition becomes false, then the control passes outside the loop. For example, in this while loop, the condition is number less than 10. That means the loop will keep on iterating till the number is less than 10. That is, till when it becomes equal to 9. And inside the loop, after printing the variable number, we are incrementing the variable because we want to increment the variable number after each iteration. Now, moving on to functions. Functions in C++ are a group of statements that are designed to perform a specific task. It allows us to write a code inside the function, and then we can use that code every time when we need it by simply invoking the function. We can also pass arguments to the function. The syntax of function is type, function name, and then the parameters. Inside the function brackets, we can write the code and we can invoke the function by calling it from the main function. So as we have understood these concepts, so let's move on to our code editor, that is VS Code, to do some examples on these concepts. So here we will do an example in which we will find the number of even elements and odd elements using array, for loop, and if-else statements. So let's first of all make a new file. Let's name this file as basic.cpp. Okay, so first of all we'll include the header files. Now we'll write using namespace standard. Now we will include int main and int main, and here we will declare an array arr, and we'll write and we'll mention the elements 2, 7, let's say 12 and 9. Okay, now first of all we'll initialize the variables. Let's say int even 0, and we'll initialize odd variable with 0 as well. Now we'll write int length because we want to find size of the array, and for that we'll write size of array name, then divide size of array of 0. So now I'll explain this part. Here we have an array which has 5 integers, and since size of an integer is 4 bytes, therefore size of array is 5 into 4, that is 20 bytes. Now int length, we have written int length equals size of array divided by size of array of 0, that is 20 divided by 4, that is equal to 5. So 5 is the size. Here size of array of 0 is the size of element at index 0. We can take any index here, like array of 1, array of 2 or array of 3. So now we know the length of the array. So here we will include the for loop, and we'll start with int I equals 0. We have initialized I with 0. Now I less than length, this one. Here I have written I less than length, that is I less than 5. Okay. Now I plus plus, we are incrementing it. Now we have to use if condition because we want to find the even elements and the odd elements, and for that we have to include if condition. So we'll write if array of I mod 2, that is if an element on dividing by 2 gives 0 as a remainder, then it is even element. So we'll increment the even variable, this which we have initialized 0 will increment over here. Okay, so now in else block we'll write odd plus plus. It means that if this condition is not true, then the odd variable will increment. Alright, now we will print the variables. So we'll write even numbers, and we are printing these outside the for loop so that they don't repeat with the for loop. So that is why we have printed these outside the for loop. Okay, now we'll write the variable even, and L for the new line. Similarly we'll write odd numbers. The variable odd, and after that we'll write return 0. Okay, so this is the code. So now let's try to run this one. There is some error. Okay, yeah, the spelling is wrong. Yeah. Okay, let's try again. Yeah, here it is. As we can see, even numbers 2, odd numbers 3. We can check it, like even numbers 2, 12. There are 2 even numbers, and 179 there are 3 odd numbers. So in this question we have used array, for loop, and if else. So now let's try some other example. Okay, let's name this as basic2.cpp. Alright, first of all we'll include the header file #include iostream. Now using namespace standard, okay, now we will do an example in which we will print the elements from 1 to 20 using while loop and with the help of function. So first of all we'll start with int main, and inside int main we'll simply call or invoke the function by writing the name of the function. This is the name of the function, print function. Okay, so here we are calling this function, and after that return 0 we'll write. Okay, now we have to make this function. Let's create void. Void is the data type, print function is the name, and inside this function we'll first of all initialize I, the variable I, with 1. Now we'll use while loop and we'll write the condition I less than equal to 20. This means that the loop will keep on repeating until I becomes less than equal to 20. So basically it will move from 1 to 20 times. In total the loop will repeat for 20 times. So now all we have to do is we'll just print the I variable, and in order to give some space between each element while printing, so that is why we have used double quotes with a space between them. Now we'll increment I++ so that I will increment after each iteration. Alright, now here we have called this function and it is getting printed inside the function itself. So let's try to run this one. Here we can see this is the output: 1 2 3 4 5 6 7 8 9 10 up to 20. As I have told you, as you have put the condition less than equal to 20, so that is why 20 is also getting printed, because we have used equal to over here. So we have called the function print function, and inside that function we have initialized the variable I with 1, and we have put the condition I less than equal to 20. So that is why the loop is getting repeated for 20 times and I is getting printed inside the loop. And after that we have used increment operator so that the value of I gets updated after every single iteration. So this is the output. So now let's move on to the next example. So let's make a new file and name it as basic3.cpp. So here we will do an example of string and we'll do some push back and pop back operation on it. So first of all we'll include the header file #include iostream, then using namespace standard Okay, now we'll start with int main. Alright, first of all we'll write string data type, then the name of the string s. Here s is the name of the string. Alright, now first of all we'll display a message to enter a string. So okay, enter a string. Now get line, this is the syntax when you want to take the input of a string. So get line cin is used to take the input and s is the name of the string. So this is how we take the input, and now we will print another message saying that you have entered Now here we will print the string s. next line, and L. Okay, now we'll do some operations like s dot pushback. This will add an element at the end of the string. So let's say we want to add y. So we'll write y inside the bracket, s dot pushback, and inside the bracket with single quotes we'll add y. Now we'll display a message saying after using pushback function, we'll print the string. That is, after using the function pushback, the string would look like this. And now we'll use another function s dot popback. It will delete the element from the end. So we'll write cout and we'll display the message after using popback function. Let's write popback only, and we'll print the string. Okay, now after that we'll write return 0, and I think it's done, only the spelling is wrong over here. Okay, yeah, now let's try to run this. As we can see the message, enter a string. So let's say I have entered Barcelona. So you have entered Barcelona after using pushback Barcelona y, because we have used y over here. We want to add y at the end of the string. So after using pushback Barcelona y and popback function after that we have used, and we know that it will delete the element from the end. So here we can see there is no y. Popback function have deleted the element. So this is our output, and these were some basics examples of C++ basics. It includes the examples of array, for loop, if else, and functions, strings we have covered. And there are some more examples on each of these topics, so I suggest you to please practice them all, and that is how you will get a good understanding on all of these topics. So you can try some more examples on it. Why do we need classes? To understand this, we need to know that C++ is an object-oriented language, and it also introduces the concept of real-world entities. So in order to describe the real-world entities, we need two things, that is, characteristics and functions. And a class is a mechanism of binding these two methods together in a single unit. Also, class has its own members like functions, variables, constructors, destructors, etc., which are commonly used in C++. And class has an important role in the concept of inheritance as well. Now, let's understand what is a class. Classes are one of the most important features of C++ that leads to object-oriented programming. It represents the set of properties that are common among all the objects of same type. A class basically represents a group of similar objects which holds its own data members and member function together. And this is the basic syntax of a class. First is class keyword, which is used to create class. Then after that we will write the name of the class. Then inside the name of the class there is access specifier that can be private, public, or protected. After that there is data members, that is the variables, and then the member functions, and also class body must be surrounded with braces. Now let's discuss access modifiers. It basically grant permission or set the restriction for data members of the class. Access modifiers in a class are used to provide accessibility to the class member. For example, In a school, teachers are allowed to see the question papers before the exams, but the students are not allowed to do so. Anyone other than teachers cannot access those questions. Now, we can relate these teachers to data members of class which have access, and students are outside functions that do not have the access. So there are three types of access modifiers: private, public, and protected. Private members can only be accessed from within the class. That means outside data members and member functions cannot access it. Public, as the name suggests, it can be accessed from within the class and from outside the class as well. Protected members can be accessed from within the class but cannot be accessed from outside the class. But with the help of friend function, it can be accessed from outside the class as well. Now let's learn about object of a class. An object is an instance of a class. It is a real-world entity that contains state and behavior. When we create an object of a class, then the memory is allocated and no memory allocation occurs when class is defined. And we can create as many objects of a class as we need. In this example, state is the class and st is the object name or reference variable. So this is how an object is created. Now coming to member functions. Member functions are also known as methods. These are as much as part of the class as the member variables. These member functions can be invoked by sending messages through an instance of a class with the help of dot operator. For example, if the name of the object is obj and we want to access a function named sum, then it will be obj.sum. Here obj is the name of the object and sum is the name of the function. Now let's learn about constructors. Constructors can be defined as a special type of method that is invoked automatically whenever an object is created. Its main use is to initialize objects. It doesn't have any return type and a constructor has the same name as that of the class. And it is of two types, parameterized and non-parameterized. The syntax for parameterized constructor is class name, which is a constructor name, and then arguments inside the bracket. In non-parameterized constructor, the syntax is class name with empty brackets, as there are no parameters in non-parameterized constructors. Now, after constructor, let's discuss the destructor also. Destructor, as the name suggests, is also a special method that destroys or destructs the object as soon as the scope of the object ends, and it is automatically invoked when the object goes out of the scope. Its name is same as that of the class but with the tilde sign. Here is the syntax of destructor: tilde sign with constructor name or class name and then empty brackets. Now to do some examples on classes, let's move on to our code editor, that is VS Code. Now here we will make a new file and let's name this file as class.cpp. Now here we will do a program in which we will make a class, and inside that class we will make some functions, and with the help of objects of that class we will call those functions. So let's start. First of all, we'll mention the header files #include iostream. Now using namespace standard. Now let's make a class, and with a class keyword, and name this class as, let's say, franchise. Now here don't forget to mention the semicolon. Now here we will write the access modifier, that is public Now we'll mention those functions. Let's say void Let's name this function as KFC. Now inside this function we will print something like, let's say, we have the best chicken. After this we'll write endl. Now we'll make another function named Burger King. As we know that these two are famous franchise, so that is why we have put this under class for franchise. Now let's print here we have the best burgers. Now we'll try to print these two functions with the help of objects that are made from the class franchise. So what we'll do is we'll write int main. After the franchise class we'll write int main, and inside this class we'll make an object of class franchise. Franchise is the class name, fran is the object name. Now all we have to do is the calling. We'll call the function KFC and we'll call the function Burger King with the help of fran object. So let's do this. Fran dot operator KFC, that is the function name. After that we'll write fran dot Burger King, return 0. Now let's try to run this one. Here it is. Actually I have run it twice, so that is why it is getting printed twice. We have the best chicken, we have the best burgers, that is what we want to print. First here friend.kfc, call this void KFC inside this class franchise. After that friend.burgerking, call this function Burger King. So that is why they have printed serial wise. We have the best chicken, we have the best burgers. After this we'll do another example. So let's do this. First of all we'll name this file class 2.cpp. Okay, I think it already exists. We have to name it something else. 3. Okay, now we will write the header files. Hash include iostream. Now using namespace standard. In this example we will try to access a private variable, as we know that it can only be accessed from within the class, but it can be done with the help of setter getter methods. So let's start. First of all we'll write int main. Now we'll make an object. For that we have to write the class name, which is billboard. We'll make this class afterwards. First of all we'll write the class name, after that we'll write object. Let's name the object bill. Billboard is class name, bill is the object name. Now we will call a particular method or a function which we call setter method. So we'll write bill dot, we'll name that setter method as set title. Basically this function will access or assign the value to the private variable which we were talking about. So we'll write here, let's say top 5 songs of 2020. We want this title to be written on the billboard. Now we'll write the getter method. Basically the setter method or set title method will set or assign the value of to the private variable, and get method or get title method will return that value from there. So we'll write bill dot get title. Now because we want to print it, so that is why we'll write it in cout. Okay, now after that we'll write return 0. Now we will make the class billboard. Class keyword billboard. After that bracket starts. Now we will write private because we want the variable to private. So the data type string and the variable is title. Now this variable is private and we want to assign the value to this variable, which is not possible because they are not of the same class, but we will do that with the help of setter getter method. So let's do that. Now we will write public because we want our functions to be public. Now void, that is the data type, set title, and inside the bracket we'll write the variable. Now this method is taking this parameter x, so we'll assign this parameter x to the private variable. Let's do that. Title, that is the private variable, x. Now we will write another method named get title. There are no parentheses in get title method because this method is only returning the value. So we'll write return title. Now get title function or method is returning the value of private variable title. So here what happening is, here the function set title, which is public, is taking a parameter x and is assigning to the title variable. So the message will get assigned to the title variable. Now get title function is returning the value of private variable title, which is getting called in the main function. One more thing, we forgot to put semicolon over here, and we get title cannot be void because it is returning. It would be string because it is returning some value. Now, so basically bill.setTitle in the main function will set the value or assign the value to the private variable, and bill.getTitle will return the value of that private variable, which will get printed. So now let's try to run this. top 5 songs of 2020. Here we can see it is getting printed. So this is how we can do that. We can access the private variable using setter and getter method. Now let's do another example. Let's name this as class 4.cpp. Now here we will do the same example, but we will do it with the help of constructors. So let's continue. First of all, we'll write hash include iostream. After that, using namespace standard. Now here first of all we'll write int main. Now we'll name the class, we'll write the name of the class, that is billboard, and we'll make the object of it as we have done previously, like bill. Now we'll make a constructor of this object and we'll pass the parameters. We'll pass the string as top 3 songs of 2020. As we are passing this string to the constructor, that means the constructor is parameterized constructor. And now we'll write bill dot get title. Here we are writing this because this function is returning the value of private variable title. So that is why we have to write it. And we'll print it actually cout. Return 0. Now let's do the other thing. As we have done previously, we'll write class billboard. We are making this class, and inside this class we are making the variable private. String title is private. Now we'll write public access modifier. Now here we will write the constructor in which we were passing the string from the main function. So we'll write the name of the constructor. As we all know, the name of the constructor is same as that of the class, so it would be billboard, and the parameter is b. That parameters which we are passing from the main function is getting stored in b. Now inside this constructor we'll call the method setTitle. So we'll write setTitle. We are passing the same string to the setTitle method. Now we'll make this method setTitle. We'll write void setTitle string a. So actually what is happening, we have passed a string named top 3 songs of 2020 to the constructor. The constructor is further calling to the method or function named setTitle and is passing that string to the same function. Now that function is setTitle, and now we will assign that string to the private variable title. So let's write title equals a. A is that string. Now as we have done previously, we'll write void get title. Now get title function is used for returning the value of private variable, as we know. So we'll write string actually. String get title, return title. Semicolon. Now let's try to run it. I think something is wrong. Here capital S we have written. Let's make it correct. Now let's try to run again. Here we can see top 3 songs of 2020. So this is how we can print with the help of constructor. This was the same example as that of the previous one, but to understand constructors we have done this with the help of constructors and we get the right output. So after this we'll do the example of destructors. Okay, let's name this as class 6.cpp. Now let's write the header files. Hash include iostream using namespace standard. Now we'll start with int main. So first of all we will write the class name, that is Gambit. To access the class we need to have an instance or object of class. Here the name of the object is gam. After this we will call a function display, so we will write gam.display. Return 0. Now let me tell you what is happening. So as we declared this object, constructor will be called, that is Gambit, and the message inside the constructor will be printed. After the constructor gets completed, we will return back to the main. Now we have gam.display, which is used to call display function inside the Gambit class. So after this we will write the class. Let's make it class keyword Gambit. Now we'll write public access modifier. Now we'll write the constructor, and inside the constructor we'll display the message. We'll write hello there, I'm a constructor, I'm in constructor. Now here we will write the destructor. Gambit, and inside the destructor we will print the message just to indicate that we are in the destructor. Hello there, I am in destructor. semicolon. But before that we have to write the function display also. So we'll write void display, and we'll print the message, let's say hello. And L. Now let's try to understand this again. As the object is declared, constructor will be called, that is Gambit, and the message inside the constructor will be printed. After the constructor gets completed, we will return back to the main. Now we have gam.display, which is used to call display function inside the Gambit class. So hello will be printed. Now as we can see, the program has finished the execution. Now the destructor will be called and hello I am destructor will be printed. As we know, destructor destroys the object as the scope of the object ends. So after the scope of the object ends, hello I am in destructor gets printed in the last. So now let's try to run this. Here we can see hello there I am in constructor, then hello is printed, then hello there I am in destructor is printed. As we have thought, destructor is getting printed in the last because as we know that when the scope ends, the destructor is called. So these were some basic examples of classes in C++. In order to understand them better, you must practice some more examples on them. Why we use vectors in C++. Vectors are used when we are not sure about the size of data. Like in case of arrays, we have to guess the size of the data first because it is not possible to resize it later. But in case of vectors, we don't have to set the size of vector and it is resizable. That is why it is more preferable for dynamic elements. And it also has some inbuilt functions like pushback, size, empty, etc., which helps in dealing with data values. Now let's understand what is a vector. Vectors are array-like containers that is used to store data, and the data is stored in contiguous storage locations. But unlike arrays, its size can be changed automatically depending on the number of elements, and it is not necessary to mention the size of vector while declaring it. Now let's have a look at the syntax here. Inside the angle brackets, this is the data type of the vector. It can be string, int, float, etc. and v2, v1, v3 are the names of the vectors respectively. Now let's understand the member functions of vectors. A vector container has three types of member functions, that is modifiers, iterators and capacity. So let's understand these functions in detail. First is modifiers. These are those functions that are used to modify data elements. For example, first is pushback function. This function is used to add a new element to the end of the vector. Next is popback. This function deletes the last element of the vector. Then there is insert function. It is used to insert a new element at a specified position. In this function there are two parameters. First parameter specifies the position and second specifies the value. After that, erase function. Erase function is used to remove the elements at a certain position or to remove a range of elements. Either you can write the position of the element you want to remove inside the bracket, or you can write starting position and ending position of the range of elements inside it. Next is swap function. This function is used to swap the contents or elements between two vectors. And if there are two vectors named v1 and v2 that we want to swap, then its syntax would be v1.swap v2. Then there is assign function. This function is used to assign values to the vector. In this function there are two parameters. First one specifies number of values to be assigned, and second represents the value that is to be assigned. Last is clear function. This function is used to remove all the elements from the vector. Now moving on to iterator functions. These are those functions that helps in iterating across the elements. First is begin function. It basically returns the iterator pointing to the beginning of the vector. The next is end function. This function returns the iterator pointing to the end of the vector. Now coming to capacity functions. These functions that lie under capacity are associated with size. So first is size function. This function returns the number of elements in the vector. Next is max size function. This function returns the maximum size that a vector can hold. Then there is resize function. This function changes the size of the container, and inside the brackets a number n is mentioned. If n is less than the size of container, then content is reduced by removing extra elements. But if n is greater than the size of the container, then extra elements are added at the end so that it reaches the size of n. After that, capacity function. This function returns the size that is currently allocated to the vector container. At last, there is empty function, which checks whether the vector is empty or not. If it returns true, then it is empty, and if false, then it is not empty. Now, to understand these vector functions in a better way, let's do some examples of these vector functions in our code editor, that is VS Code. So first of all, let's make a new file and name this file vector.cpp. Now first of all, we will write the header file, that is hash include iostream. Now we will write the header file hash include vector. This is the header file for vector because we are doing some examples on vectors, so that is why we have to use it. Now we'll write the namespace standard using namespace std. Now we'll start with int main. Now first of all, we'll define the vector, so we'll write vector, and inside the angle bracket we will write int, which is the data type. Now the name of the vector, we'll write n. Now first of all, we'll see the functionality of assign function. As we know that assign basically puts the value at positions, so we will write n dot assign. Now first of all, we'll write the number of values, like 9 is the number of values. After that, in the second parameter, we'll write the value. Here it means that we are putting 1 to 9 positions in the vector. That is, we are assigning 1 to 9 positions. Now in order to print this, first of all we'll display a message saying the contents are. Now in order to print these contents, basically we have to write a for loop. We'll write int a equals 0. We'll initialize it from 0. Then a less than n dot size. This is the size function. It basically returns the number of elements. Now a++ will increment. We have to now print this. We have to write like an array. in order to print all the elements, we'll write n and inside the bracket a. Now we'll leave some space. We'll write and l. We wrote and l over here in order to insert a new line. Now after that, we'll see the functionality of another function, that is pushback. And we know that pushback functions adds an element at the end of the vector. So we will write n dot pushback and then the element which we want to add, like let's say 2. Now we have to display this last element also. So in order to display this, we will store the size of vector in some variable and then we will print the last element. So we will write int no, this is the variable name, then we will write n dot size. Here we are storing the size of the vector in some variable no. Now we'll display last element. We'll display the message saying last element, and then we will print the last element. And as we know, in order to print the last element, we have to print the n-1th element. So we will write n bracket no minus 1. Here we are writing n bracket no minus 1. This will print the last element. After that we'll write and l. Now after that we will see another function, that is pop back. It basically removes the last element. So we'll write n pop underscore back. So this function will remove the last element that we have added, that is 2. So we need to print this also. So we'll write, first of all we'll display a message. Now the contents are now we again write the for loop as we have done previously. We'll write int a equals 0, a less than n dot size a plus plus. Now we'll again print in the form of array. And inside the bracket we will write a, then in order to give some space we'll write this. After this we'll write and l to add one new line. So firstly we displayed the contents, then we added one element at the end and then displayed that element. After that we have removed that element with the help of popback function. As you have noticed that we are just doing the functions of modifiers yet. So in this example we will cover some functions of modifiers only. Then in the next examples we will do for iterator functions and then for the capacity function. So now let's do the functionality of insert function. As we know that insert function is used to add an element at a specified position. So we will write n dot insert n dot begin. It will point to the first element, then 7. As we know that the first parameter specifies position and the second specifies the value. So n dot begin will point to the first position and 7 is the value. So now we will print it also. We'll write first element is, then we will write display the first element, then we'll write endl. Now we will use the function clear to remove all the elements. So we'll write end.clear clear, and then in order to check we will write end.size. So first of all we'll write now the size is, and in order to check whether all the elements are removed or not, we'll write end.size. It will display the size. The program is pretty long, but let's just hope it runs. Here it is. Now the contents are last element. Let's have a look whether it is right or not. 1 is displaying 9 times, then last element we have added 2, then we have removed that element. It is also correct. Then the first element we have added using insert, 7 is there, and after using clear function now the size is 0. So this is the correct output. Now after doing this function, let's try another example. Now here we will do the example of iterator functions, in which first of all we will add some elements inside the vector and then we will print them using iterators. So let's start. First of all, name this vectors2.cpp. Now first of all we'll write the header file #include iostream, then the header file for vectors #include vector, then we'll use namespace standard. Now we'll start with int main. So here we will write vector, and inside the angle brackets we'll write the data type, that is int, and then the name of the vector, that is num. Now we will write the for loop, and with the help of for loop we'll add the elements inside the vector one by one. So we will write for int I equals 0, I less than, let's say 5, I plus plus. Let's make it 1 over here. Okay, now after that we'll push these elements one by one inside the vector. So we will write the function pushback. We'll write num dot pushback, and here I will write I. Okay, now because we want to add the elements from 1 to 5, so that is why we have to use less than equal to, because we want to include 5 also. Okay, now we have to print these elements, right? So we'll write, first of all we'll display that output from the beginning to the end. Okay, now we will write for loop, and with the help of iterators we will print the elements of vector. So we'll write auto, this is the iterator and A is the iterator name. Then we'll write num dot begin as we know that begin function points to the first element of the vector, so that is why we have written num.begin. Now we will write a less than, sorry, not equal to num dot end, then a plus plus. Now after that we have written a not equal to num dot end, and we know that end function returns the iterator to the end of the vector. And after that we have used increment operator, so this loop will run from beginning till it reaches to the end. And inside for loop we will write the dereference operator with a, so that each element which is getting pointed by a will display one by one with the help of loop. So let's write, we'll write cout dereference operator a, and then we'll give some space. Now let's try to run this. This is the output from the beginning to end, 1 2 3 4 5. This is our right output. This is the message which we want to display, and this is the output 1 2 3 4 5 which we want to display, which we have added in the vector and then we have displayed. So now let's do another example which includes the capacity function. So we'll make another file, vector3.cpp. So in this example we will add some elements in the vector and then we will apply some functions on it. So let's start. First of all we'll include the header file #include iostream, then the header file for vectors #include vector, then we'll write the namespace standard using namespace std. Okay, now we will write int main. So first of all we'll write vector and then the data type and then the name of the vector, let's say v. Now one by one we'll put some elements inside the vector. So we'll write for loop. We'll start with int x equals 0, x less than equal to 10, x plus plus, because we want to add these elements. So we will write v dot push back and then we will write x inside the brackets, semicolon. Now here one by one all the elements from 0 to 10 will be added. Let's make it 1 to 10. Okay, now we will apply some functions on this vector. So let's first of all try out the size function. So first of all we'll write vector size is, and then we will write the function v dot size, and then we'll write and l. So this function will tell us the size of the vector because we have already added the elements from 1 to 10, so it will display 10. After that we will use the try out the capacity function. We'll write capacity of vector is, and then we will write v dot capacity. After that, here also we'll write endl. Now we will use the maximum size or the max size. So we'll write maximum size of vector is. So in order to calculate the maximum size, we write v dot max underscore size handle. As we know that v dot size will give us the size of the vector, and capacity function, this function returns the size that is currently allocated to the vector container, and max size, this function returns the maximum size of the vector. So all of these functions result will be displayed because we have wrote them inside cout. Now let's try another function, that is resize. Now in order to resize the vector, we'll write v dot resize, and then we'll write the number that we want to resize it with, like let's write 5. Now in order to check this also, we will display. So we'll write vector size after resizing. Resizing is, I forgot to put the commas. Okay, now we'll write v dot size, because now we want to find the size after resizing. So we have written v dot size. Now after that we will write endl. Okay, now we'll try the empty function. We'll put empty function inside if. Now inside if we'll write v dot empty equals false. It means if the vector is not empty, because we have written v dot empty equal to false, not true. We have written v dot empty equal to false. That means if it is not empty, then we'll display vector is not empty, and in else condition we will write vector is empty. So here we will write cout vec. Again I forgot to put over here. Okay, vector is not empty. And in else condition we'll write vector is empty. So in this question, first of all we have added some elements inside a vector, then we have used v dot size function, then v dot capacity function, then max size function. After that we have resized the vector and then check it for the size of it. After that we use v dot empty function. So now let's try to run this code. Okay, I think we have done something wrong. We haven't put the brackets over here. Okay, now let's try again. Here it is. Vector size is 10 because we have put 1 to 10. Then capacity of vector is 16. Okay, then max size of vector is this. Then vector size after resizing, because we have wrote the number 5 as we can see, so that is why vector size after resizing is 5. And vector is not empty, as we know, because inside the vector there are 5 elements, so it is not empty, which is true. So these were some examples of vectors in C++. You can try some more examples on it. You can practice some more examples. What is a constructor in C++? In C++, constructors are special functions that are different from normal functions. They are used to initialize objects of a class. Whenever an object is created, the constructor is invoked or called automatically. Even if we do not create a constructor, the compiler automatically creates a default constructor. Now, let's move to the declaration of the constructor. Constructors are the member functions of a class that has the same name as that of the class and it doesn't have any return type. A constructor can be defined inside the class and outside the class as well using the scope resolution operator. The syntax of a constructor is as mentioned. Inside the class cons, we can see there is a constructor which has the same name as that of class, that is cons, and we can initialize variables inside it. This constructor will be invoked automatically when the object is created. Now let's understand how the constructor is different from functions. There are some differences between constructors and functions. So the first is constructor doesn't have a return type, unlike function which has a return type. Next is the name of the constructor must be the same as that of the class, and it is not so in case of function. Third is whenever an object is created, then a constructor is invoked. And the last one is function can be a virtual function, but it is not so in case of constructors. So these are some differences between constructor and a function. Now coming to types of constructors. There are actually 3 types of constructors in C++. That is default constructor, parameterized constructor, and a copy constructor. So let's start with the default constructor. A default constructor is a constructor that doesn't have any arguments inside it. It can either be declared explicitly or can be generated automatically, which means even if we do not define the constructor, then also it is generated by the compiler. For example, here cons is the default constructor. In this case, the name of the class would have been cons. That is why the name of the constructor is cons. Now, coming to the parameterized constructor. A parameterized constructor is similar to that of the default constructor. The only difference is we can pass the arguments to the parameterized constructor. The constructor can be overloaded and also be used to initialize elements. Here is an example of the parameterized constructor. Cons is the name of the constructor and n1 and 2 are the parameters of the constructor. Now, coming to the copy constructor. A copy constructor is a type of constructor which initializes an object using another object of the class. In this constructor, properties of one object is copied to another object. This copy constructor is invoked when an object is passed as a parameter. If a class has pointers or there is some dynamic memory allocation, then it is necessary to have a copy constructor. Its syntax is as follows. Here cons is the name of the constructor and &obj is the reference of the object. As you have understood all of these 3 constructors, so let's go ahead to our next topic, that is constructor overloading. Like functions, constructor can also be overloaded, and it is pretty much the same as function overloading. The constructor must have the same names, and the difference in the number or the type of arguments will decide which constructor should be called. Here in the example, we can see 2 constructors with the same names as that of the class are being overloaded. Here the difference in the number of parameters will determine which constructor will be called. Now coming to the last topic, that is destructors in C++. Just like the constructor, the destructor is also a special function which deletes or destructs the object as soon as the object goes out of scope. It basically deallocates the memory that has been assigned to the variables. The name of the destructor is same as that of the class name with a tilde sign. The destructor doesn't have a return type and it also doesn't take any arguments. And here is the syntax of the destructor. So as we have covered the theoretical aspect of this topic, so let's go ahead to our code editor and cover the practical examples on this topic as well. So this is Visual Studio Code, and here we will do some examples of constructors and destructors in C++. So let's start with default constructor example. First of all, we'll create a new file and we'll name it cons1.cpp. Alright, so now first of all we'll write the header files #include iostream. Now we'll write the using namespace standard. Now we'll start with the main function, and inside the main function we'll create an object. So now we will create an object of a class. Let's say the name of the class is book and the object is B. Alright, let's write this. Now we have to create the class. So let's create the class book, which is the name of the class, and inside the class we will declare a variable which is private. So let's start. Pages is the name of the variable and we'll make this variable as private. Alright, after this we'll write the public access specifier, and now we will create a constructor, and inside the constructor we will initialize this variable pages. So alright, and make sure to make the constructor inside the public access specifier. Alright, now we'll assign, let's say 250 to this variable pages, that is the number of pages is 250, let's say. Now we will display a message like, let's say the name of the book is the compound effect. It's a famous book, and after that we'll write endl for the next line. Now again we will display a message which will display number of pages. So we'll write number of pages, and now we will write the variable pages. Alright, and after the class we will put the semicolon, and let's try to understand it again. When we create this object B, this constructor will be called, and this variable, that is pages, will be initialized with the value 250. Then this message will be displayed, and then the value of this variable pages will be displayed. As we can see, we haven't passed any arguments to this constructor. It is a default constructor. We have created an object of the class book, and that's how the constructor is getting called. And let's try to run this. Hope it works. Firstly we have to save it by pressing Ctrl and S. Now let's try to run it. As you can see, the name of the book is the compound effect and number of pages is 250, as that we have initialized it 250. So this is the example of a default constructor. Now let's do another example. Now we'll do an example of parameterized constructor. So let's name this first cons2 dot cpp. Alright, now we'll include the header file #include iostream using namespace standard. Now we'll start with the main function, so we'll write int main, and inside the main function we will create an object of a class, let's say bar. The object of this class would be b, and we will pass the arguments, let's say 40 and 35. Alright, by mistake we have wrote this. Alright, now after that we'll write return 0. Now let's create this class bar. So we'll write class bar, and inside the class we will declare two variables which will be private. So let's say private int, and the name of the variable is drink, and another variable would be people. Alright, now we have to create the constructor, so we'll write the public access specifier, and now we'll create the constructor which is of the same name as that of class, that is bar, and now the parameters would be d and p. So we are passing these parameters, that is 40 and 35, to this constructor, as this is a parameterized constructor. So now we will assign these parameters to the private values, that is drink and people, that is the two variables. So we'll write drink equal d, that is we are assigning the value of d to the variable drink. So, and we will do the same for p variable. We'll assign the value of p to the people variable. Once we are done with this, then we have to compute it or do something about it. So let's say we have to multiply it, so it would be total cash, like the number of drinks into number of people, that how many cash is collected by selling those drinks. So we'll create this variable int total cash. This is a function. Inside this function we will multiply the cost of a single drink with the number of people. So let's say, as the return type is int, so we have to return, we can't display over here, so drink into people, drink into people. Alright, now semicolon in the end, and we have to call this function as well. So let's do that. We'll write cout, and then we will display a message, let's say total cash collected. Then now we will call this function total cash, b.total cash. B is the object and total cash is the function. Alright, after that we have already mentioned return 0. So now save it by pressing Ctrl and S, and let's try to run this. As you can see, total cash collected 1400, and we know 40 into 35 will get 1400. That is the right answer. So as we can see, here we have created this object B and passed these arguments 40 and 35, and this is the parameterized constructor bar. These values are then assigned to these variables drink and people, and then we have called this function b.totalCash, this function over here, and the value by multiplying drink into people is 1400. That is 14 to 35 equals to 1400. So this is the example of a parameterized constructor. Now let's create a new file and we'll do an example of constructor overloading. So let's name it first cons3.cpp. So here we will do an example of constructor overloading. So first of all, we'll write the header files hash include iostream, then namespace standard, then again we will start with the main function, and inside the main function we will write the name of the class. Let's say the name of the class would be overload, and the name of the object is O1. So here we will create a parameterized constructor. So that is why we will send two arguments, let's say 20 and 4, and we will create another object overload O2 because we want to do constructor overloading. So we have created O2 object, and here we will pass, let's say, 3 arguments. So we will pass, let's say, 50, 65, 30. In the first object, in the first constructor, we are passing 2 arguments, that is 20 and 4. In the second constructor, we will pass 3 arguments, 50, 65 and 30. Alright, now let's write return 0, and now we can create the class, let's say class overload. Now inside this class, first of all we will create this variable result res. Alright, inside this, after this we will declare public access specifier and we will create the constructors. The constructor would be a parameterized constructor because we are passing the arguments. So overload is the name of the constructor with an capital O, and we are passing 2 arguments in the first constructor. So int x comma int y. Now in this we will multiply and we will store it in this res variable. So x into y. Alright, after this the second constructor, and in this constructor we are passing 3 arguments, and as you can see the name of both the constructors are same as that of the class, but the only difference is the number of arguments. In this constructor we are passing 3 arguments, and now we will store the sum of all of these 3 variables, x plus y plus z. Once it is done, we will put a semicolon in the end, and now we have to somehow display the result. So we will create a function, int is the data type, result is the name of the function, and we will simply return the variable res. And now we will call this function inside the main class. So before that we will display a message. Let's say result of multiplication is, right, O1 dot res, O1 dot result, sorry, because result is the name of the function and we are calling the function. After that, end line, then we'll write result of addition is, then we'll write O2 dot result and semicolon, and we have already mentioned return 0. So let's save it by pressing Ctrl S and let's try to run this. There is some error. Okay, this is a scope error. We have to include this function inside this class. So let's say now let's try to run this by, after saving this, let's run it. Alright, by mistake we write this wrong. Alright, now let's save it and now let's try again. Here it is, result of multiplication is 80 and result of addition is 145, as you can see, and 20 into 4 is 80, and when we add 50 plus 30, 80 plus 65 would be 145. So our result is right and we have successfully compiled the program and run it. So in this example we are doing the constructor overloading, as we are passing these two arguments to this constructor with same name as that of this constructor, and we are passing 3 arguments to this constructor, and we are not actually calling them, we are just creating the object and passing the arguments. Okay, now let's do an example in which we will use destructor as well. So let's create the new file and name this as cons4.cpp. Alright, now let's include the header files. Now namespace standard. Alright, now we'll write int main. Inside int main we will write the name of the function. Let's say the name of the function is formula1 and f is the object. And now we will pass the parameters, let's say 370 and 4. Here we are passing the speed and the pickup of a particular car, and let's make it f instead of d. So f is the object and formula1 is the name of the class. After that, for now, let's say return 0, and now we will create a class formula1. We'll declare 2 variables which are private, int speed and int pickup. Now we will create a constructor which is parameterized. Before that we will use public access specifier And now we'll create this constructor formula1, and the parameters are int s comma int p. Now inside it, first of all, we'll display a message saying that this is a constructor. Alright, after that we'll write endl. Now we will assign the parameters to these variables. We'll assign the value of s to speed and the value of p to pickup. Alright, after that we'll make a function display, and we can display inside this function as the data type is void. And so we'll write speed is, then we'll write the speed variable and endl as well. Then we'll write pickup is pickup variable, then endl. Alright, now we can create a destructor. We'll use tilde sign, then formula1, which is the name of the constructor. Then here we'll write a message so that we get to know that we are inside the destructor. So we'll write formula1, inside it we'll write this is a destructor. And the sign is, here it is. Now we'll write semicolon after the class. And so first of all, as the object is created, the parameterized constructor is called. 370 and 4 would be assigned to these variables, speed and pickup. And then using the function, here we will call this function display. So we'll write f, which is the object, dot display, which is the name of the function, and that's it. Then once the values are assigned, then these values will be displayed when this function is called using the object f. And then this is a destructor is called as the destructor is called in the end of the function when the scope ends. So when the scope of class object is ended, then this is a destructor is displayed. That is why we have displayed this message. So after saving it, let's try to run this. Here we can see this is a constructor. First this is getting printed, then speed is 370, pickup is 4, and this is a destructor, as we can see, is getting printed in the last. And if we just cut it over here and just paste it here, and we can just paste it over here and save it, and let's try to run this again. There's a variable by mistake we have wrote. Alright, now save it and run it again. As we can see, this is a constructor, speed is 370, pickup is 4. This is a destructor, it is again getting printed in the last. So this shows that the destructor deletes the object as soon as the object goes out of scope, that is in the last. So these were some examples of constructors and destructors in C++. You can try some more examples on it It will help you in understanding this topic in a better way. What is memory management? Memory management can be defined as a process in which management of a computer's memory occurs. For example, assigning memory to programs, variables, etc. in such a way that it doesn't affect the overall performance. Sometimes the computer's data can range up to terabytes. So efficient use of memory is necessary so that we can minimize the memory wastage and boost up the performance. Now, let's understand why we need memory management in C++. Memory management is required so that there will be no wastage of memory and to make sure that allocation takes place efficiently. During the declaration of an array, there are times when the correct memory is not determined until runtime. And to avoid such cases, we usually declare array of maximum size. And because of this maximum size, some memory remains unused. For example, let us suppose we have declared an array of size 30. And after declaring the array, it turns out that we only need space of 10 size. So the rest of the space is of no use, or we can say it will get wasted. To avoid such cases, we use memory allocation. So let's understand memory allocation and deallocation in C++. Other programming languages like Java, Python, etc., they don't need to allocate memory dynamically. In C language, we use the malloc or calloc functions to allocate the memory dynamically at runtime. And these functions are also supported by C++. But in C++, allocation and deallocation is done manually. In C++, there are two operators that are used for the allocation and deallocation of memory. That is new operator and delete operator. So let's understand this new operator in C++. The new operator in C++ is used for the dynamic memory allocation. It is used to allocate the memory at runtime. The general syntax of new operator is pointer variable, which is the name of the pointer, equal to new, which is a keyword, and data type is the type of the pointer. The syntax for arrays is almost the same, but after the data type, we have to write the size inside the brackets, which specifies the number of elements in an array. And here in the example, we first of all are declaring a pointer ptr of int data type. After that, we are dynamically allocating the memory using new keyword, and at last we are assigning the value 75 to the allocated memory. Coming to the delete operator. The delete operator in C++ is used for the deallocation of memory. When we no longer need to use the variable, that means the memory is no longer required, then we have to deallocate or release the memory using the delete operator. Syntax for delete operator is delete keyword with the name of the pointer variable. The syntax for arrays is delete keyword following the empty brackets and then name of pointer variable. As we can see in the example, once the printing of value is done, we have deallocated the memory using the delete operator. Moving on to the advantages of new operator. The new operator and delete operator can be overloaded unlike the malloc function. Next is, return type of the new operator is of the same type for which the memory was allocated. We don't need to use the typecasting. Third is, the new operator automatically computes the size of data object. We don't need to use the size of operator. Next is, new operator in C++ allows us to initialize object while creating memory space for them. So these were some advantages of the new operator. So now let's move on to our code editor, that is VS Code, to do some examples on the new operator and delete operator. Here we will do an example using new and delete operator in C++ that will allocate the memory location for 3 values and find their average. So first of all, let's create a file and name this file as mm1.cpp. mm means memory management. So now first of all we'll include the header files. Hash include iostream. Now using namespace standard, now we'll start with int main. Okay, so first of all we'll create 3 pointer variables. So we'll start int star ptr1, int star ptr2. We are creating 3 pointer variables because we have to find the sum of 3 variables, so that is why we have to create 3 pointers also. And now we have to store the sum of 3 variables into some another variable, so now we'll create the variable average. Okay, now we will allocate the memory dynamically using the new keyword. So we'll write ptr1 equals new int, which is the data type. Same we will do for ptr2 equals new keyword int. Here we are allocating the memory dynamically with the help of new keyword. New int. Sorry, M is there. Now we will print the value that is stored in the memory. But before doing that, as we have allocated the memory, so now we will take the input from the users of those 3 variables of which we have to find the average of. So we'll display enter first number. After displaying this, we'll take the input from the user, we'll write cin, and using the dereference operator, we'll write ptr1. Here we are taking the input from the user for the first memory location. Now we'll take the input of the second number from the user. For that we have to print the message again. Enter the second number. Yeah. Now we'll take the input using the dereference operator with the pointer. Now same goes for the third one. Enter the third number. Dereference operator ptr3. As we have taken all the 3 numbers from the user, now all we have to do is to find the average of these 3 numbers, as we know that dereference operator will point to the variable. So that is how we'll get the access for the variable. Now we'll write the variable avg, that is average. We know that dereference operator will display the value that is pointer pointing at. So we are actually adding the values ptr1 plus dereference operator ptr2 plus dereference operator ptr3 divided by 3. This is how we can find the average. After that, all we have to do is to print the average. So we'll write average is avg, that is the variable, as the result is getting stored in this variable avg. So we'll print that variable, and once everything is done, once the printing is, then we have to deallocate the memory, and we will deallocate the memory by writing delete ptr1. We have to do this for all of these 3 pointers. Delete ptr2, because we have allocated the memory for all of these 3 pointers, so that is why we have to deallocate for each one of them. Okay, now everything is done, and let's try to run this. Here we can see enter the first number. So let's say 5. We have to find the average of 3 numbers, so we'll select the easy number to check whether it is right or wrong. Then we'll write 5 again. Now we'll write 2. As we know that 5 plus 5 equals 10 plus 2 equals 12, and the average of 12 is 4. Yeah, 3 4s are 12. So this is the correct output. So first of all, we have allocated the memory over here dynamically, then we have deallocated the memory using delete ptr1, ptr2 and ptr3. So this is how it's done. So let's do one another example. Let's name this as mm2.cpp. Okay, we'll write mm4.cpp. I think 2 and 3 are already taken, so we'll start with hash include iostream. Hash include iostream, then we'll write using namespace standard. So in this question, we'll simply enter the elements of the array, and then we will display those elements, but we will use new operator and delete operator in this question. So let's start. First of all, we'll write int main. Now inside int main, first of all, we'll write the variable size. We have declared the variable size, and this variable size is the size of the array which we will take as an input from the user. So first of all, we'll display enter the size. Enter the size. Now we'll take the input size. After that, we will declare a pointer variable ptr. Alright, now here we will allocate the memory for the complete array. So we'll write ptr new keyword int, which is the data type, and here size. Okay, here we are allocating the memory for the complete array of size that we will enter. Okay, now we will display the message saying that enter the elements. As we have allocated the memory, all we have to do is to enter the elements. We'll use a for loop. So we'll start with int I equals 0, I less than size, I plus plus. Now we'll write element, and after this we'll take the input from the user for the elements of the array. So we'll write cin Now just like arrays, we can do it for the pointer as well. We can write ptr, and just like arrays, inside the bracket I, and we can do it for the output as well. So here we are taking the input of the elements from the users. Now we have to display those elements. So for that, first of all, we'll display a message, elements that you have entered. Now we'll use for loop again. Int I equals 0, I less than size, I plus plus. Now we'll print those elements. So first of all, we'll write element now ptr, like just we did earlier, ptri, and end line, so that the output looks good. Now everything is done. We have allocated the memory, then we have taken the input from the user and displayed the output. Now all we have to do is to delete the operator. So we'll write delete, then empty brackets, ptr. Alright, now everything is done. We have allocated the memory, and here we are deleting the allocated memory. Okay, now let's try to run this. Here we can see enter the size, let's say 4. Now enter the elements 3, 6, 5, 7, and here is the output, elements that you have entered 3, 6, 5, 7. That is right, but it is not looking good. Let's use /n over here, and now let's again try to run this. Enter the size 4. Now 2, 4, 7, 9. Here is the space between them. Now it is looking good. Enter elements that you have entered are 2, 4, 7, 9. So this is how it's done. We have allocated the memory to an array of size variable. Then we have entered the elements. Then we have displayed those elements, and at last we have deallocated the memory using delete operator. So these were few examples on memory management, C++ memory management. You can try some more examples on them. What is operator overloading? Operator overloading is a special case of polymorphism in which the operator is overloaded to provide special meaning to the user-defined data type. Basically, it adds some features or redefines the functionality of already existing operators. For example, let us suppose we have 3 objects of same class, namely A, B, C, and C equals A minus B. Now here we can redefine how minus operator works, and we can write C equals A minus B instead of writing C equals to A dot subtract B. And this is the general syntax of operator overloading. First is the return type of the function. After that, operator is the keyword, then symbol is the operator we want to overload, then the arguments are those which are passed to the function. Now let's move on to the non-overloadable operators. There are some operators in C++ that cannot be overloaded because it is not syntactically possible to overload them. First is the dot operator, then next is scope resolution operator, and third is pointer to member operator, and at last we have ternary operator. Coming to the next topic, that is types of operator overloading in C++. So there are two types of operator overloading, that is unary operator overloading and binary operator overloading. First is unary operator overloading. It is defined as an operator which contains only one operand or works on only one operand. Increment operator and decrement operator are examples of it. There are two ways to do operator overloading, that is from the class function and the friend function. Its syntax using class function is the return type, operator keyword, then the symbol and the brackets. But if we are doing postfix in the function, then we have to write the data type inside the brackets. Syntax using friend function is friend keyword, return type, then operator keyword, after that symbol, and in case of friend function we have to pass an argument. Next is binary operator overloading. An operator which contains two operands or works with two operands is called binary operator overloading. Addition, subtraction, multiplication are examples of binary operator overloading. Syntax using class function is return type, then operator keyword, then the symbol, and then we have to pass an argument inside the brackets. And syntax using friend function is friend keyword, then the return type, after that operator keyword and then the symbol, and in case of friend function we can pass two arguments. Now we will do one example of unary operator overloading in which we will increment the value of the variable with the help of operator overloading. So now let's move on to our code editor, that is VS Code. So here first of all we'll make a new file and name that file as operator.cpp. Now first of all we'll write the header files #include iostream. Now we'll write the namespace standard. Now we'll start with int main, and inside int main first of all we'll write the name of the class, that is increase, and its object inc. Now we will call the void operator increment function, so we will write ++inc. Here when we write ++inc, then function void operator ++ will be called, which we will make later. So as of now first of all we write inc.display in order to display the output. We are calling the display function over here. Now after that we'll write return 0. Now we'll make the class. So we'll write class increase, which is the name of the class. Now we'll use the access specifier private and we'll write the variable int value. Now we'll write another access specifier public, and now we will make the constructor because we have created the object inc, so that is why a constructor is called, and we are making it increase. And inside the constructor we have given the value 10 to the variable. Now ++inc is calling the void operator ++ function, so we'll write that function void operator increment, which is the symbol. Now value equals value +5 because we are incrementing the variable with 5, so we'll write value equals value +5. Now after that we have to display the value variable, so we will write void display, because we have already called over here inc.display. So now we will write inside cout, we'll write the message value is Now the variable value and endl. After the class we have to use the semicolon. Now let's try to run this. Here is our output. Value is 15. Previously the value was 10, then on increment its value gets 15, which is the right output. So here first of all we have created an object and constructor is called, and inside the constructor we have initialized value with 10. Then with the help of object inc, that is when we are using plus plus inc, then we are calling the void operator function, which is increasing the value of the variable by 5, and then we are displaying it with the help of display function. And one more thing guys, in case of postfix, that is in case of inc++, we have to write the data type inside the void operator function, that is over here. Now let's do another example for binary operator overloading. So let's name this operator 2.cpp. Now here we will do one example of binary operator overloading in which we will add two complex numbers. So let's start. First of all, let's make the header files. Hash include iostream. Now using namespace standard, now we'll write int main. Okay, now first of all we will write the name of the class, that is complex. So we'll write complex, and then the objects like com1, com2, res. We have created 3 objects. Now we will write a message because we have to take the input from the user. So first of all we'll write a message. Enter first complex number, because we have to add two complex numbers. So first of all we'll take the input of the first one, that is /n. Okay, now we have to write com1 dot input. Input is the name of the function which we will be creating afterwards. Then cout enter second complex number. That is, now we'll write /n. Okay, now after this we have to write the semicolon and we'll write com2 dot input. These input function will take the input of complex numbers from the user. We will declare them later, we will make them later. Okay, now here we will do an operation with the help of plus operator function. So we will write res equals com1 plus com2. This function call from com1 will go to the complex of operator plus function, and com2 will be passed to the argument obj, and the result will be stored in variable res. Okay, now we will call another function output in order to display the output. Res.output. After that we'll write return 0. Now we will make the class complex. We'll write class complex. We'll write the access specifier private and the variables int real and int imag, that is imaginary, because we know in complex number there is a real part and imaginary part. Okay, now we'll write public access specifier, and now we will write the function input in order to take the input from the user. Void input. Now first of all we have to display a message. We will write enter real and imaginary parts respectively. Okay, now we will write cin because we have to take the input and the variable name real and imaginary. Now we will write the overloading function. We'll write the return type, that is the complex, then operator keyword, then symbol, then argument, complex obj. Okay, now we will write complex temp. So here we have created the data type temp of complex class. We'll make it a capital C. Okay, now we will write temp.real equals to real plus obj.real. So we'll write temp.real equals to real plus obj.real. The plus operator over here will add the real part of the number to the real part of another number. And similarly we'll do it for the imaginary part. We'll write temp.imaginary equals imaginary plus obj.imaginary. And then the value of the variable temp is returned. So we'll write return temp. The value was stored in temp, so that is why we have returned temp. Now we will make the output function. We'll write void output. We'll write output is variable real, then we'll write plus, then imaginary, and then I, because this is the syntax for complex number. Okay, now we have to put the semicolon over here. As the value of temp is returned, now the result is stored in variable res, and then we will print the output using the output function. This is the output function, and the value is stored in res, and then we are printing the output using the output function. Com1 over here is getting passed to the complex of operator plus function, and com2 is getting passed to the argument obj, and the result is getting stored in res. Now let's try to run this code. The first complex number, let's say 2 plus 2 iota, so we will write 2 and 2, and then enter second complex number, that is enter real and imaginary parts respectively. Now we have to write the real and imaginary parts of the second complex number, so we'll write 4 plus 6 iota. So the output is 6 plus 8 iota. 2 plus 4 equals 6 and 2 plus 6 equals to 8. So this is our correct output. We are basically adding two complex numbers with the help of binary operator overloading. So this is how it is done. So these were some important examples of operator overloading. You can try some more examples on it in order to practice them well. What are exceptions? Exceptions are the unexpected events or the situations that arise during the smooth execution of the program. So there are times during the runtime when some errors or situations arises which create issues in the program. These issues are called exceptions. For example, let us suppose we want to divide two numbers, one is 7 and other one is 0. Now if we divide 7 with 0, it will show an error because we cannot divide any number by 0 because it is undefined. So exception handling provides a way to take care of problems like these. So now let's learn about exception handling, but before that we must understand why we need exception handling. So why do we need exception handling in C++? One of its reasons includes handling the exceptions that arise during the execution of the program. Along with that, exception handling provides a mechanism through which we can handle the error generating part separately from the rest of the code. Exception handling provides information to the user about the problem so that he or she can detect the mistake and correct it. Now, let's go ahead and understand what exception handling is. As we have discussed, exception handling helps in dealing or handling the exceptions that disrupts the flow of execution of a program. So how does it deal with the exception? So when an exception is encountered, it transfers the control from one part of the program to the other, known as handlers, and makes the code more readable and maintainable, and takes care of the exception by providing certain code. These exceptions are handled with the help of exception handling keywords. Now let's understand these exception handling keywords. So there are three exception handling keywords named try, catch and throw. As we can see in the example, first there is try block, then followed by three catch blocks, and each catch block contains the name of the exception. The try block can have more than one catch block. Inside the try block, those statements are enclosed which may cause the exception. Or we can say, in this block, that particular code is kept which will throw the exception. Each try block is followed by one or more than one catch block. The try block throws an exception which is caught by the catch block. Taking care or handling the exception is the actual job of catch block. This block catches the exception thrown from the try block. Inside the catch block, a message or some code is written to handle the exception. It can be a message for the user or a default code for a particular condition. Both the try block and catch block work together, and every try block has at least one catch block for it. Now next is throw keyword. Whenever an exception is encountered, it helps in throwing the exception. It is used to throw an exception and its value to the consecutive exception handler. So as we have discussed this topic theoretically, now let's go ahead and do its practical implementation in our code editor, that is VS Code. So this is our code editor. Here we will do an example in which we will make sure a person who is less than 24 years of age is not allowed to drink in the club. So we will create an exception in that part, and with the help of try, catch and throw blocks, we will handle those exceptions. Alright, so first of all, we'll create a new file and let's name it as exception1.cpp. Alright, now we'll start with the header files, that is hash include iostream. Now the namespace standard. Now we'll start with the main function. And inside the main function, first of all we will declare a variable named age. So we'll write int age equals to, let's assign it as 20. So this person is 20 years of age, and now we will create the try block. So inside this try block, we will write an if condition, that is if the age of the person is greater than equal to 24, then only he is allowed to drink. So inside this we will print a message saying that you have the access to drink the alcohol. Alright, so after this, inside the else block, all we need to do is to throw and the exception, that is if the age of the person is not greater than 24, that is age is less than 24. So in that condition or in that situation, we will throw the exception, that is we will throw age to the catch block, and for that we have to create the catch block. So the catch block will catch the exception, that is age, as you can see. Now inside this catch block, first of all we will write a message. We'll write you don't have the access to drink alcohol. You don't have because your age is less than 24. Alright, so after this message, we will print the age of the person. So we'll write your age is so and so, and then the variable age. Now after that we'll write return 0. So in this example, as we can see, the person age is 20 as we have assigned, and inside the try block we have set a condition that if the age of person is greater than 24, greater than equal to 24, then he or she have the access to drink the alcohol, and if not, if his or her age is not greater than 24, then we'll throw the exception and the catch block will catch the exception and will print this message that you don't have the access to drink alcohol because your age is less than 24, and then his age will be printed. So now let's try to run this. I hope it works. As you can see, you don't have the access to drink alcohol because your age is less than 24 and your age is 20. And now let's try to, if we assign, let's say 25. The program is working fine, but we want to check the other condition as well. Okay, so it is happening because we forgot to save this 25. As we have now saved it, Now let's try to run this. As you can see, you have the access to drink alcohol because now our age is 25. So this is how exception handling works. This try block, inside this try block we kept those code or statements which will throw the exception, and then it is thrown with the help of this throw keyword, and then the catch block solves or prints a message with respect to that exception. So now let's do another example. So let's create a new file and name it, let's say, exception2.cpp. Alright, so here we'll do an example in which we will try to divide a number by 0, and as we know that we cannot divide a number by 0, so it will throw an exception. So let's do this example. So first of all, our hash include iostream, the header file, then the namespace standard. Now inside the main function we will create 3 variables. Main. So inside the main function we will create 3 variables. One is for the numerator, then denominator, and then in which we will store the output, that is the output variable. So let's name numerator as num and denominator as denum because it is sounding familiar. Then we'll store the output in the output variable. Alright, so we have created 3 variables, num, denum and output. Now first of all, here we will display a message to enter the numerator and denominators. So we'll write, please enter the numbers to do the division. Alright, after that endl. Now we'll take the input C in num and C in denum. So the numerator and denominator we have taken the input from the user. Now after that we'll make the try block. So inside this try block we will create an if condition and we'll write if denum, that is the denominator, is equal to 0. If it is equal to 0, then we will throw the exception, and the exception would be denum because denominator cannot be 0, and if the denum is not 0, then in else condition we will simply divide. Output equals to num divided by denum. Alright, so now after this we have to create the catch block also because we have thrown the exception. Now we want the catch to catch the exception. So we can write D for denum here. Now we'll print a message saying that you cannot enter 0 in the denominator. So we'll write you cannot enter 0 in denominator while doing the division operation. Alright, now after that we'll use endl. So this is our catch block. After this catch block we will again write a message that the output of the division is, that is, if the denominator is not 0, then we have to print that result. So for that we will do this, the output after the division is, and here we will write the variable output. So this will print the result of this one where the denominator is not 0. So after that we can write return 0. So there is one extra bracket, as we can see, of try block. Alright, now it's done. We can save this one and let's try to run this. But before running this one, let's go through this code. That first of all we have declared these three variables. Then we ask the user to enter the numerator and denominator. So then we have used this try block, and inside the try block we have set the condition that if denominator is 0, then we will throw the exception, and if it is not, then we'll simply divide both of the numerator and denominator. So the denominator which is thrown is called by this catch block, this, and it will display a message that you cannot enter 0 in the denominator while doing the division operation because it is undefined. And if the denominator is not 0, then it will simply print the message and the output. So now let's try to run this. So as we can see, please enter the numbers to do the division. So let's say the first number is 8 and second number is 0, that is denominator is 0. Then you cannot enter 0 in the denominator while doing the division operation. The output after division is 0. So it will show this output only, and our output is correct. Now let's try to run this and do the simple division operation in which the denominator is not 0. So let's say now again we'll write 8 and the denominator would be 2. Then as we can see, the output after the division is 4. So our code is correct and our output is also correct. So this is how we can do the exception handling and handle the exceptions using this try, catch and throw blocks. Well, there were some limitations in earlier approaches to programming, and OOPS helped to fill those gaps. In object-oriented programming, it is easy to maintain the code with the help of classes and objects. And with the help of inheritance, there is code reusability. That is, we don't have to write the same code again and again, which increases the simplicity of the program. Now, let's understand what is object-oriented programming. Object-oriented programming is a programming pattern where the programs are structured around objects rather than logic and functions. In other words, OOP basically focus on objects that are required to be manipulated instead of logic. For example, let us suppose we have made blueprint of a mall. Then that blueprint will be a plan that explains what properties the mall should have and how it should look like, etc. But it is just a blueprint of the mall. We cannot go inside it physically as of now. Now the constructors will go through the blueprint and they will construct the mall, and they can make as many malls as they want with the help of that blueprint, and each mall can have its own different shops and showrooms. In this case, blueprint is the class, the mall is the object, and the shops and showrooms inside the malls are data stored in the object's properties. And these are some basic concepts of OOPS. First is classes, then objects, then data abstraction and encapsulation. Then there is inheritance, polymorphism, dynamic binding and message passing. We will learn about these concepts later. First, we will discuss the difference between OOPS versus procedural programming. Procedural programming follows top-down approach. Here top-down approach means fragmenting a bigger complication into smaller chunks. OOPS follows bottom-up approach, and bottom-up approach means piecing together smaller tasks to give rise to complex tasks. In procedural programming, overloading is not possible. In OOPS, overloading can be done. In procedural oriented programming, there are no access specifiers. In OOP, they have access specifiers like private, protected, public. Procedural oriented programming is less secure. OOPS is more secure because of the concepts like abstraction and encapsulation, which are used for data hiding. Now, let's learn the basic concepts of OOPS. First is class. Class can be defined as collection of objects. It is a logical entity. Then there is object. It is defined as an entity that has state and behavior, or in other words, anything that exists physically in the world is called an object. Inheritance can be defined as when one object acquires properties and behavior from its parent class. It provides code usability. Polymorphism. Polymorphism is a combination of two words, poly, which means many, and morphs, which means forms. It is basically an ability to exist in more than one form. Next is abstraction. Hiding the internal details and showing the functionality to the user is called abstraction. Then encapsulation. Encapsulation is the binding of code and data together into a single unit. Dynamic binding. Dynamic binding is the method called at runtime that means which code will execute is unknown until the program runs. Then there is message passing. It is basically a communication that exists between the objects. As we have gone through some concepts of OOPs, now let's discuss some benefits of OOPs. In OOPs, code can easily be reused with the help of inheritance and object. We don't need to write the same code over and over. Second is, with the help of abstraction and encapsulation, certain parts of program can be hidden and it helps to make a secure system. Third is, maintaining and modification of code is easy in object-oriented programming. Now, to do some examples on the concepts of OOPs, let's move on to a code editor, that is VS Code. Now here we will do a program of inheritance in which we will make a parent class and a child class, and we will call the attributes using object of child class. So let's get started. First of all, let's name the file. oop.cpp. Okay, so first of all we'll add the header files hash include iostream. Now adding namespace standard. Now we will write int main. So we want to create the object of child class. So first of all we'll write the name of class child, that is child. Let's put C capital child, and now the name of the object ch. So now we will call the attributes using this object. So we'll write first of all display it. So we'll write cout ch dot name 1, which is the attribute. We will declare it later. So basically we want to write both the names of both the classes together, so that is why we are doing like this. We'll write name2. Name1 will be the attribute of the parent class and name2 will be the attribute of child class. So after that we'll write return 0. Now we'll make the parent class and the child class. So first of all let's write class parent. We'll name it as parent. Then we'll write public access specifier. String is the data type. Name1. Let's write Harley. Okay, now it is mandatory to write the semicolon at the end of the class. Now we'll write the derived class, that is child. We will write the colon symbol Then we will write public name of the parent class, that is parent. So here we are writing the child class is derived from the parent class. Now within the bracket we'll write public, then string the data type, name 2, we'll write Davidson. It's a popular bike brand, Harley Davidson. So now we'll write the semicolon over here. Now we'll try to run this. As we can see, Harley Davidson. Here Harley is from the parent class and Davidson is from the child class. So as we can see that we are calling from the object of child class and still we are able to access the attribute of parent class. So this shows that the child class inherits attributes or properties from the parent class. Now as we have done one example of inheritance, so now let's do one example of polymorphism also. Let's name it oop1.cpp. First of all, we'll include the header files. --include iostream stream. Now we'll write using namespace standard. After that we'll write int main. Now here we will do an example of polymorphism in which we will make a base class and its derived classes, and inside these classes we will override a function which is common in all of these classes. So let's start. First of all, we'll write the name of the parent class or base class, animal, and we'll make an object A. After that we'll write the name of the child class cheetah and its object name is seal, let's say. Now another derived class dolphin, and we'll name the object as D. Now while making these classes, we'll write a function named speed in all of these classes, inside all of these classes, and now in order to override that function we'll call them. So first of all we'll call it by the object of animal, that is a dot speed. Now c dot speed, this is the object of cheetah class. Now d dot speed. After that we'll write return 0. Now let's make these classes. First of all we'll make the animal class, that is the base class. Animal. Now we'll write the access specifier public. Now we'll write the function void, that is the data type speed. Now we will display a message inside this function. Let's say it displays who is more faster, who is more faster. Okay, now we'll put a semicolon in the end. Now we will make a derived class, that is dolphin. We'll write class dolphin child of animal class. Okay, so now inside this class we'll write public and we'll make the same function speed. And we'll display a message saying, as this class is of dolphin, so we'll write I'm faster in water. We'll put semicolon. Now we'll make another child class cheetah. Okay, C is capital, cheetah. Public animal. Now here we will write public access specifier and we'll write the same function void speed. And over here we'll display a message saying that I am faster on the ground. Semicolon. So now as we can see that a.speed is calling this speed function in animal class. C.speed is calling this cheetah function in cheetah class, and D.speed is calling the dolphin speed function in dolphin class. Okay, so now let's try to run this. Okay, the output is here, but it is not in very good form, so let's put /n in the end. Okay, /n. /n. Okay, here it is. So first who is faster is displayed, then I'm faster on the ground, then I'm faster in water is displayed. So as we know that first of all we have called the animal class, so that is why who is more faster is displayed. After that we have called the cheetah class and cheetah says that I'm faster on the ground. Then dolphin class, then dolphin says I am faster in water. So here we can see that each of the class have its different implementation for the same function, that is speed, and this is how polymorphism allows us to do a single action in variety of ways. Okay, now let's do one example of abstraction. Let's name it as oop3.cpp. First of all, we'll include the header files. We'll write hash include iostream. Now we'll write the namespace standard using namespace std. Now as we know, abstraction helps in data hiding, so in this program we will make a variable named coupon as private, and with the help of setCoupon function we will try to assign some value to the coupon variable, and after that we will display it. So let's start. First of all we'll write int main. Now we'll write the name of the class, that is trade fair, and now the name of the object t. Now with the help of this object, we will call a function named setCoupon. I would say coupons. And we will pass 50 as an argument to this function. Now we'll display a message coupon, and after that we will call getCoupon method in order to display the number of coupons. So we'll write t dot get coupons and brackets, done. After that we'll write return 0. Now let's make the class and the functions. So let's start. First of all, we'll write class trade fair. Now we'll write an access specifier private and private. Now we will declare a variable coupon, and as I've already told you, we will make this variable as private, so that is why we have used this access specifier as private. Now after that we will write public access specifier to write a function that is setCoupons. setCoupons, and the parameter is C. As we know that we have passed 50 to this parameter, so now we will write the private variable coupon equals C. So here we are basically assigning the value of C to the coupon, that is we are assigning 50 to coupon variable. Now after that we will make another function and we'll put its data type as int because it is returning something. So we'll write int get coupon and we will return variable coupon. Now as the class ends, we will write semicolon. Now let's try to run this code. There is some error. Okay, we haven't write S over here. Now let's again try to run it. Coupon 50, as I've told you. So here we have assigned 50 to this function and the variable C is assigning 50 to the variable coupon. Now after that we have used getCoupon function to return the value of coupon, and that is why it is getting displayed over here. So we got our answer, that is coupon 50. And as you can see that in this example we are not allowed to access the variable coupon, but still somehow we have managed to do that with the help of some functions. So this is an example of abstraction and it helps to increase the security of the program. So these were some basic examples of OOPS in C++. In order to understand it better, we must practice some more examples on it. What is inheritance in C++? Just like a child inherits the behavior and characteristics from his or her parents, Similarly, inheritance in C++ is a process in which the derived class acquires all the properties and characteristics from the parent class, that is the base class. Derived class is also known as child class, and base class is also known as parent class. Inheritance is one of the most important feature of C++ OOPS, that is object-oriented programming. In inheritance, there are two types of classes. The class which inherits the properties and behavior from the base class is known as derived class, and the class whose properties or characteristics are inherited is called a base class. Now, let's understand why we use inheritance in C++. Inheritance is used in C++ because it increases the reusability of the code and it helps in removing the redundancy. To understand it, let's suppose there are two classes, two-wheeler and four-wheeler. Both of the classes contain similar functions like color, brand, and mileage. Now, if we create these classes, we have to create all the three functions in both of the classes. Or in other words, we have to write the same code two times in both of the classes. So instead of writing that code again and again, we can use inheritance and create a parent class named class vehicle. And both of the two-wheeler and the four-wheeler classes will be inherited from this parent or base class. Now with inheritance, we have inherited both the classes from one base class, that is class vehicle. Now we no longer have to write the code again and again, and we can simply write the functions once in the base class, as both of these classes are inherited from the base class vehicle. So as we have understood about inheritance in C++ and why we use inheritance in C++, so now let's go ahead and learn about modes of inheritance. There are three modes of inheritance in C++, that is public mode, protected mode, and private mode of inheritance. So let's start with the public mode. In this mode of inheritance, the public members of base class remains public in derived class, and same goes for the protected members. That means inside the base class, the class members that are public will remain public in the derived class, and similarly protected class members will remain protected in derived class. Now protected mode. In the protected mode, the public and protected members of the base class will become protected in the derived class. That means the class members which are public or protected in the base class will all become protected in the derived class. In the private mode of inheritance, protected and public members of class will become private in the derived class. So now let's go ahead to the types of inheritance. So there are various types of inheritance in C++, that is single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So let's start with the single inheritance. In this type of inheritance, a single derived class is inherited from the single base class. It allows the derived class to inherit properties and behavior from the parent class. The derived class objects can access the members of the base class, but the base class objects cannot access the members of the derived class. So now let's have a look at the syntax. As we know, this is single inheritance, so there will be only a single derived class and a single base class, and this is how we derive a child class from a parent class. Class keyword, then the name of the derived class, then the colon operator. After that there is an access modifier with the base class. Now as we have understood about single inheritance and its syntax, now let's move on to multiple inheritance. Multiple inheritance. When a class inherits from more than one base class or multiple base classes, then it is known as multiple inheritance. It allows us to inherit properties and characteristics from more than one base class. Syntax for multiple inheritance is class keyword with the name of derived class, then the colon operator and access modifier with the name of the base class separated with comma and the name of another base class. Here we have shown only two base classes, but we can make more than two base classes depending upon our requirement. Now coming to multi-level inheritance. In this type of inheritance, the derived class is inherited from another derived class. That means when a class extends a class that further extends another class is known as multi-level inheritance. For example, if there are three classes A, B, C, and class C is inherited from class B and class B is inherited from class A, then it can be called as a multi-level inheritance. Syntax of multi-level inheritance is as follows. Base class 2 is derived from base class 1 and the derived class is derived from base class 2. These base class 1, base class 2 and derived class are just the names, not a syntax. You can write whichever name you want with the class. Now let's learn about hierarchical inheritance. In this type of inheritance, more than one class is inherited from a single base class. That is, there would be a single base class and multiple derived classes, which have the properties and features same as that of the base class. As we can see in the figure and in the syntax, the derived class 1 is derived from base class, and similarly derived class 2 and derived class 3 are also derived from the base class. So this was hierarchical inheritance, and our next type of inheritance would be hybrid inheritance. The hybrid inheritance is the combination of more than one type of inheritance, and it can be said that it is a combination of multi-level and hierarchical inheritance. In the figure we can see the base class 1 is the parent class of derived class 1 and derived class 1 is the parent class of derived class 3, which makes it multi-level inheritance. But if we look at it in this way, that the base class 1 is the parent class of derived class 1, derived class 2 and derived class 3, then it is hierarchical inheritance, as multiple classes are inherited from a common base class. So we can say it is a combination of more than one type of inheritance or a hybrid inheritance. So as we have understood about inheritance in C++, so now let's go to its practical aspect and do some examples on our code editor, that is VS Code. So this is our Visual Studio Code, and now we will do an example of inheritance. We'll start by doing the single inheritance example, in which we will make a parent class and a child class. And let's start. First of all, we'll create a file, and let's name this file as, let's name it inherit.cpp. So here we will do an example in which we will create two classes, a base class and a derived class, and we'll create functions in those classes, like we'll create one function in base class and one function in derived class, and using the object of derived class we will access the member of parent class or base class. So let's start. First of all, we'll include the header files, hash include iostream. Now the namespace standard using namespace std. Now we'll create a base class first, then afterwards we'll create the main function. Alright, so let's create the base class. Let's say the name of the base class or the parent class would be beverage, and inside this class let's make the scope public, and now let's create a function, as we have said, drinks. So this is a function and we will print something inside this function. So let's say we are printing all drinks are available. All drinks are available. Now we'll write endl. Now we will use semicolon in the end of the class. So this is our base class and we have created a function drinks, and we have printed a message, all drinks are available. Alright, now we will create another class which is derived class or child class. We will write class coffee is the name of the derived class, and use the colon operator, public access specifier, and the name of the base class, that is beverage. Alright, now we'll write public access specifier inside this class, and we will create a function in this class also, like let's say the name of the function would be mocha. It is a kind of a coffee, so mocha, and we will print that mocha tastes good, tastes the best, I would say. Okay, now let's use the colon operator in the end of the class. So here we have created the parent class or base class and this derived class or child class. So now we will create the main function where we'll do the calling. So now we will create the object of child class. So our child class is coffee, and now we will create the object, that is C, the name of the class and the object. Okay, now we will use the object with dot operator and call this function, that is drinks. and now using the same object we'll call the mocha. The spelling is wrong. Yeah, now it is right. Mocha. So using the object of child class, here we are calling the drinks function, which is of the parent class. So let's see if it works or not. Let's save it and now run it. As you can see, all drinks are available and mocha tastes the best. Both of these are getting printed. That means the object of child class is able to access the member of the parent class. So this is inheritance, when the child class acquires or inherits the behavior or characteristics from a parent class or access the members of the parent class. This is an example of single inheritance. So now let's do another example of multiple inheritance. So let's create a new file and name it as inherit2.cpp. Alright, now here we will do an example of multiple inheritance in which we will create two base classes and a derived class. As we know that in multiple inheritance there are more than one base classes to a single derived class. So let's start. First of all, we'll include the header file. Now we'll use the namespace standard, and now we will create a class that is the base class and we'll name it as party. So class party. Inside this base class we will first of all declare the public scope, and now we will declare a variable, let's say meals. So now we will create a function, and in this function we will take the input from the user about the number of meals to enter the number of meals. So let's start void food. This is the function name, and first of all we'll display the message saying that enter number of meals. Alright, now we will take the input and meals is the variable. Now we will use the semicolon at the end of this class. So in this function we are taking the input of the number of meals. Now in the other class, that is another base class, we will take the input of number of drinks from the users, and then in the derived class we figure out the total bill of the party. Alright, now we will create another base class, that is drinks, not drinks, drinks. Alright, now we'll write the public scope, and similarly we'll create or declare another variable drink, and then now we will create a function. Let's say the name of the function is liquor. Alright, now inside this function we will take the input from the user regarding the number of drinks. So we'll display the message enter the number of drinks. So the user will enter the total number of drinks used in the party or consumed in the party. Similarly goes for the meals. Now we will take the input and we'll write drink. Alright, now we have created this liquor function. Now we will use the semicolon at the end of the class. So here we have created both the base classes, that is class party and class drinks. Now we have to create the derived class. So this is an example of multiple inheritance. So we will create the derived class and use the colon operator. Now we will write the public specifier, and the name of the base class, first base class would be party, separated with comma. The second base class would be drinks. Alright, so this is how we can do that. Now inside this class we will first of all create three variables. Let's say int total meals, int total drinks, and int total bill, because in the end we have to find out the total bill. Alright, now inside the public scope we will create a function name as total. Now inside this total function we will write the logic to calculate the total bill. So what we'll do is, first of all write the total meals equals meals into the price of a single meal. Let's say the price of a single meal is 90. So the total product would be stored in total meals. Alright, now we'll do same for total drinks. Total drinks, not frinks, equals drink into, let's say the price of a single drink is 60. Yes. Alright, now after that we have to compute or calculate the total bill. Total bill would be the addition of both of these, total meals plus total drinks. So we'll simply do the addition over here. Total drinks. So once it's calculated, we'll simply display a message saying that the total bill for the party is, and we'll write the variable that is total bill, where the total bill is actually getting stored. Alright, after this we will use the semicolon. So this is the derived class. Here we have calculated the total money spent in the party. So now we have to write the main function where it all started. Inside the main function, first of all we will create the object of child class. So we know that our child class or the derived class is bill. So bill is the derived class and b would be the object. So using this b, we will first of all call a function that is food function. So by calling this, we will take the input of number of meals. Now we will call another function named liquor. Alright, using this function, calling this function, we will take the number of drinks from the user. Now we will call this total function. So this will calculate the total money spent in the party, and after that let's say return 0. We are calling all of these functions using the object of derived class, and this is where multiple inheritance is going on. So let's see whether it works or not. We will save it and we'll try to run this. Enter number of meals, as we can see. Enter number of meals. Let's say the number of meals would be 20. It was a short party. Then enter number of drinks. 17 would be. So our total bill for the party is 3270, which is the correct answer. So this is how we can do multiple inheritance, and this is a fine example of multiple inheritance. Now let's do another example. So let's name this one as inherit3.cpp. Alright, so here we will do an example of multi-level inheritance, and we know that in multi-level inheritance a single derived class is inherited from another derived class, or in other words we can say a class extends a class which further extends another class. Then it is called a multi-level inheritance, as the name suggests. So we will do example of that. In this example we will calculate the marks of a student scored by him in 3 subjects. We will calculate the total marks scored by him using multi-level inheritance. So let's do this. So first of all we will include the header file #include iostream. Then we will write the namespace standard. Now we will create the class, base class chemistry. Alright, in this class first of all we will make the public scope and marks1. So here we will take the input of marks scored by that particular child in this chemistry subject. So we'll create the chemistry function, void chemistry. It is of same name as that of class, so let's say chemistry marks. Alright, now we will display the marks scored in chemistry. Enter the marks scored in chemistry. Spelling is wrong. Okay, now we'll take the input marks1. So the student will enter the marks. After that let's put semicolon in the end. Now we'll create another class named physics, which is inherited from chemistry class. That is, chemistry class is its base class, chemistry. Alright, so in this class we will do the same, public int marks2. Now we'll write void physics marks. We'll do the same as we have done in the previous class. So now we will display a message saying that enter the marks scored in physics. Alright, now we will take the input cin marks2. Alright, So now we will put semicolon in the end of this class as well. So now we know that this physics class is inherited from this chemistry class. That is, the chemistry class is the base class of physics class. Now we'll do same for maths, like class maths, which is inherited from the physics class. We will write physics. Inside this class as well we'll do the same, and as you can see, this physics class is the base class of maths and the base class of physics class is chemistry. So this is a multi-level inheritance. So in this class we'll do the same, public scope, and now after public scope int marks3 is the variable we have declared, and we will declare another variable in this one like total, because we have to find out the total marks. Now function maths marks, inside this one we will display the message that enter the marks scored in maths. Alright, now we'll take the input marks3 and we'll write the semicolon in the end. So here we have created all of these three classes, which is of multi-level inheritance. As you can see, we have taken the input from the user of its maths, physics and chemistry marks. Now we'll do the total. So we have to do the total inside this class only. So the name would be result function. So the total variable that we have declared is equal to marks1, marks2 plus marks3. So physics, chemistry and maths marks, we will add all of them and then we will display the total. Alright, now this is done. Now we have to go to the main function. Now first of all we will create the object of child class maths. Once this object is created, now we can call the functions, as it can access the base classes. So chemistry marks first of all, then m dot physics marks, m dot maths marks, and then the total, that is result function, m dot result. Then we'll write return 0. So return 0. So here first of all m dot chemistry marks will call this function in the chemistry class. So the user will enter the marks scored by him in chemistry. Then this will call physics marks, so the user will enter the marks scored by him in physics subject. Then similarly we will maths marks, they will enter the marks of maths. Then we will call the result function. We will do the total of all the marks scored by the student. We will do the total and then we will display that total. So pretty much it's done. Now we can save it, and now let's try to run this one. There are some errors. Alright, that's a silly one. By mistake we have done this. Alright, now let's save it and run it again. Hope it works now. Yeah, another error, marks. Now let's try again. Now it's working fine. Enter the marks scored in chemistry. Let's say 80. Physics 80. My maths is weak. Let's say 75. 235. Which is the right answer? 80 plus 75 is equal to 235. And using the object of child class, we have called the functions of all of these base classes. Like we have called this chemistry marks function and this physics marks function, which is of base class. And this was a fine example of multi-level inheritance, and this is how we can do multi-level inheritance. So these were some examples of C++ inheritance. You can try some more examples on it, and these were some decent examples. To understand it better, you can start with some basic level examples, then go to the intermediate level. Encapsulation is a very important concept of object-oriented programming. It can be defined as wrapping up of data and functions together into a single unit. Just like a capsule, the data members and functions are wrapped together. Wrapping them into a single unit helps in keeping them secure from the outside access. For example, inside a class, the variables and functions are declared and then bind together with the help of class, which also implements encapsulation. Next is, why do we need encapsulation? Hiding the details or attributes is also an important thing that one should focus on. Encapsulation helps with that part. It keeps the details of the object hidden or safe from the users by securing them from the outside access. There are many implementation details that the users are not supposed to see. So these details, like the details of the object, are kept secure from the direct access from outside the class with the help of encapsulation. The data hiding is done with the help of access modifiers. So let's understand these access modifiers. The access modifiers helps in data hiding part. The access modifiers provides or grant the access to the members of the class, or it prevents them from the direct access to the class members from outside the class. So there are generally three types of access modifiers, that is public, private and protected. So let's understand them. In public access modifier, other classes and function can access the data members and member functions of the public class. For example, park is a public property. Anybody can go to the park or access the park because it's a public. Nobody has to take the allowance of anybody to go to the park. Now coming to the private. In private access modifiers, only the member functions inside the class have the access to the class members. Functions outside the class cannot access them. For example, a house is a private property. Any member outside the family cannot access the house without permission. Only members inside the family can access it because it's a private property. Now let's understand protected. In protected access modifier, similar to private scope, it cannot be accessed from the outside class, but it can be accessed from the derived class. The derived class is also called the child class. Also, the protected member of a class can be accessed from the friend function. So as we have understood about these access modifiers, now let's understand the benefits of encapsulation. Encapsulation helps in reducing the complexity of code by hiding the irrelevant data or information, and by doing so, it reduces the complexity. Second is, encapsulation helps in hiding and protecting the data by wrapping the data and functions together, which are generally complex, and by doing so, provides a simpler view to the user. With the help of encapsulation, the variables of the class can be hidden from other classes. Third is, encapsulated classes can easily be altered using the access modifiers. That is, we don't need to change the entire program. All we need to do is to change the access scope of the variables that can be private, protected or public. So these were some benefits of encapsulation. Now let's go ahead and understand the difference between encapsulation and abstraction. Both of these concepts are similar in some ways, but now we will discuss their differences. So let's start with encapsulation. Encapsulation helps in combining the data and functions together in a single unit, whereas in abstraction, the unwanted information is kept hidden. Encapsulation helps in hiding the data and helps in providing an easier view. Abstraction helps in hiding the implementation details. Encapsulation can be implemented using an access modifiers, whereas abstraction can be implemented using abstract class and interfaces. In encapsulation, problems are solved at implementation level, and in abstraction, problems are solved at design level. So these were some differences between encapsulation and abstraction. Let's go ahead and do some practical examples on this topic.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So this is our code editor, that is Visual Studio Code, and now let's create a new file and let's name it encapsulation.cpp. So first of all, we know in encapsulation we can make variables inaccessible by making their scope as private. So in this example we will do that. We'll make the salary of an employee as private, and then using the setter and getter methods we will set the value of salary and return it as well. The setter-getter methods are generally used in these kind of situations where the variable we want to access is private. So now let's start. First of all, we will create the main function, but before that let's add the header files. Now using namespace standard, now we'll start with the main function, and inside the main function first of all we'll create an object by declaring the class name. Let's say the class name is company and the object name is obj. Now using this object we will call the set function, or we can say the setter function. We will name it as set salary, let's say, and we will pass two values, 30,000 and 6,000. One would be the full-time salary and one would be the overtime. Alright, now after that we can display those, and we can write total salary and after that we can call the get function to return the salary, as the getter function is used to return the output and set function is used to set the values. So we'll write obj.get salary. So the salary we will display over here, and after that we can write the return 0. Now the main function is done. Now let's start with company, class company, and inside this class, first of all, inside the private scope, this is the private scope and this is the variable salary. Now this variable salary is private, so no member outside the class can access it. But using the setter and getter methods, we will access this variable and we will set the salary and then we will return it. Alright, now public scope, inside the public scope we will write the setter methods, void set salary and int full time, int overtime. So these are two variables. This 30,000 that we are passing is a full-time salary and this 6,000 is an overtime salary. So we need to add both of these salaries in this part. So we'll write salary equals full-time plus overtime. So this would be the total salary, and let's just do this. Alright, so this set salary function is done. This is the setter function. Now we have to return using the getter function, so we'll write the data type int get salary. Now inside this function we will simply return the variable salary, as we can see, and once the class we'll use this semicolon. Alright, pretty much everything is done, and now we can save it and let's try. As you can see, total salary is 36,000 as 30,000 plus 6,000, so it is working fine. So this is how we can access these private variables using these setter and getter methods. Now let's do another example. This example of encapsulation will also be pretty much the same. We'll do the setter getter methods in this one as well, but in this example we'll find the area of circle. Alright, let's start then. First of all, we'll include the header files, that is hash include iostream, and the namespace standard. We also forgot to save this. Let's name this one as, first of all, the location is work. Now let's name it as encapsulation 2.cpp. Alright, now the header files are added. Now we'll start with the main function first of all. Now inside this main function we'll create an object. First of all, we'll write the name of the class, that is ball. Now the name of the object is obj. Now using this obj object we will call the setter function, that is the set area function, and we will pass the radius. Alright, obj dot set area, this is the setter function. Now we will pass the radius. Now we can display the area by calling that getter function, but before that we will display a message. We'll write area of ball is alright. Now we will call that getter function, get area. Alright, the main function is done. Now we need to create the class. Class ball. Inside this class, private scope. Inside the private scope we'll create that variable area, and let's make its data type as float, because we know that there are chances that the answer could be in decimal form, because we have to use pi in that, because the area of circle is pi r square, so 3.14 is the value, so that is why we are using float as the data type. Alright, now in the public scope we'll set the radius inside this function, set area and int radius. This is the radius, that is 6 that we are passing. This is the parameter, and inside this function area equals, we know that pi r square is the formula, so we'll write 3.14, that is the value of pi, into radius again into radius r square. Alright, so this is the area of circle or ball, we can say. After that, float is the data type. Now we have to return the area using the getter function, float getter. Its name is get area, and we'll simply return the area variable. Alright, after that we can use semicolon in the end, and pretty much everything is done. So let's save it and let's check it if it is running fine or not. As you can see, area of ball is 113.04. So if we multiply 3.14, that is the value of pi, with 36, that is 6 into 6, it will give you 113.04. So this is the right answer, and this is how we can find the area of ball or something like that. And as we can see here, the area is private, and using these set area and get area methods, that is the setter and getter methods, we are accessing this private variable, that is area. So these were two examples of encapsulation. You can try these examples as well. What is polymorphism in C++? Polymorphism is an important topic of C++ OOPS concept. The word polymorphism is derived from two words, that is poly, which means many, and morphs, which means forms. So basically it means many forms. Polymorphism in C++ can be defined as when the member function or the object behaves differently in different situations or circumstances. Then it can be called as polymorphism. For example, a mother has different relationships with different family members inside the house. For example, she is a parent to her child, she is a wife to her husband, she is a sister to her brother, and she is also a daughter to her parents. So we can say a mother as a single entity has different behavior among different members. And same goes for polymorphism, where functions behave differently in different situations. Now, let's understand the types of polymorphism. There are two types of polymorphism in C++, that is compile time polymorphism and runtime polymorphism. So let's start with compile time polymorphism. As the name suggests, this type of polymorphism occurs during the compile time, and it is achieved by overloading the function or overloading the operator, that is, by function overloading or operator overloading. So what is this function overloading? Function overloading is a feature in C++ where the functions having the same name but different in terms of parameters or type of parameters can be overloaded. For example, as we can see, two functions with same name func differ in the type of arguments. One data type is double, another data type is integer. So when we make a call to the function with arguments of type double, it will invoke the suitable function, and the same goes for the other one. In example 2, there is a difference in number of parameters among functions. So while calling the function, if we pass two arguments, it will invoke the first function, and if we will pass three arguments, then it will invoke the second function. Then next is operator overloading. Like functions, operators can also be overloaded. In operator overloading, we can redefine the functionality of the operator. It helps us in redefining the already existing operator. For example, instead of writing sum equals s1.add s2, we can easily write sum equals s1 plus s2. That is, we can redefine the plus operator and use it to add the numbers in the operator function. And we will discuss the syntax of operator overloading in the examples. Now, coming to runtime polymorphism. In this type of polymorphism, the functions are invoked during the execution of program, that is, during runtime. This runtime polymorphism can be achieved through function overriding. So let's understand this function overriding. In function overriding, the function of the base class gets a new definition in the derived class. In this, more than one function has the same name and same type of parameters. The only difference is in the definition of both the functions. That is, functions have different definitions in the parent class and the child class. As you can see in the example, void message function has a different definition in the parent class and in the child class. Both have the same name, but in parent class it is printing hello there, and in child class it is printing nice to meet you. By using the object of the base class or derived class, we can invoke the suitable function. So let's move on to our next topic, that is virtual function. Virtual function is also used to achieve runtime polymorphism. It is a function that is defined in the base class and then is redefined in the derived class. The function is defined using the word virtual in the base class, and the name of the function is same as that of the derived class, having different definitions as shown. It tells the compiler to perform the late binding on the function in derived class. The function call is resolved at runtime and in late binding, and the compiler determines the object type at runtime. With the help of virtual function, we can invoke the derived version of the function in the derived class. So as we have covered the theoretical aspect of C++ polymorphism, so let's go ahead and cover the practical aspect of this topic in our code editor, that is VS Code. So here we will make a new file and let's name it as poly1.cpp. Alright, poly1.cpp. So let's save it. So here we will do an example of function overloading, which is used to achieve compile time polymorphism. And we know function overloading is a feature in C++ in which two functions have same name but differ in terms of parameters or number of parameters, or the type of parameters can be overloaded. So let's start. First of all, we'll write the header file #include iostream. Now using namespace standard. Alright. So now we will create a class king, and inside that class we'll do the overloading. So the class name is king, and inside the class, first of all, let's make public scope. Now we'll create a function. Return type is void, and the name of the function would be pro. Inside this function, let's say we are passing two arguments, int a and b. Alright, now we'll print both of these arguments or variables inside this function. Alright, and we'll use endl in the end. Okay, after that we'll create another function, and the name of the function is same, that is pro, but in this case we'll make the arguments like int a, int b, int c, int d, and int e. So there are 5 arguments in this function, second function pro. As we know that the name of the function is same, and now inside this function we'll simply add all of these. So a plus b plus c plus d plus e. Alright, once we are done with this, we'll use semicolon in the end of the class. Alright, now we'll start with the main function. Inside the main function, we will create the object of king class, king, and the object would be k. With the help of this object k, we will call these functions. As we know, the name of the functions are same. The only difference is in the number of arguments. So I'll call the pro function, which accepts only 2 arguments. So the first pro function will be invoked. So I'll pass 10 and 20. So these 2 arguments will be passed over here. Alright. Similarly, now we'll call the pro function again, but now we'll pass 5 arguments so that the second pro function would be invoked. So let's say I'm passing 12, 23, 20 and 62, 6. These are some random numbers. Alright, now return 0 in the end. Now let's try to run this. I think we are done with this. First of all, let's save it, and now let's try to run this. So this is our output, 10, 20. Let's multiply both of them. It will look good. Let's save it and run it again. As you can see, 200 and 123. So this is our output. 10 into 20 would become 200, and if we add all of these, we'll get 123. So this is our correct output. So this was the example of function overloading, and let's start with another example. So now let's create a new file and name this file as poly2.cpp. Alright, we have saved it. Now here we will do an example of operator overloading. As we know that in operator overloading we give definition to already existing operators, or we can say we can redefine the functionality of already existing operators. So let's start. First of all, we'll include the header files as we have done previously. hash include iostream, then the namespace standard. So first of all we'll start with the main function, and inside the main function we will write the name of the class that we will create and the object. Let's say the name of the object is O1, and we'll pass the arguments to the constructor. Let's say the argument is 6 and 8. Alright, then I think we can write return 0, and we'll do the rest afterwards. First of all we will create the class. So as we know that the name of the class is overload, so let's create it, class overload. And inside this class, inside the private scope, we'll start with the variables. Let's say the first variable is n1, and let's declare another variable n2. Then we will create the public scope. Inside this we will create the parameterized constructor, so it is of same name as that of the class, that is overload. And now as the constructor is parameterized, so int num1 and num2 are the parameters. So when we'll create this object O1 and we'll pass these arguments, so it will go here. And alright, inside this, in the definition of this constructor, we will declare the variable res, and we will assign num to n1, we'll assign num2 to n2, and let's say we'll do the subtraction. Alright, n1 minus n2. Alright, now we will display the result, that is res. So res, and then the variable res. After that we'll use endl. Alright, so once we are done with this parameterized constructor, then we will create a operator function. So void is the return type, then we will write operator keyword. This is the syntax of operator function. Then after writing the keyword we'll write the symbol. Let's say minus is the symbol. Then the arguments, if there are any arguments, then we can put those. Then inside the function, that is in the definition, we can perform whatever the functionality we want to perform. So let's say in this case we'll just make the numbers negative, so we'll do that. Alright, now we'll do the calling part of this. We'll simply use the symbol and the operator, and this is how we'll call the operator function. This is very simple, and after that we have to display the digits as well, as we have made them negative in this part. So we'll create a function display, and inside this function we will display those digits or numbers. So we'll write n1 alright, after this we'll do same for n2, so we'll write n2, then there is endl in the end. Alright, so here we are displaying this. So once we are done with this, the class is finished, so we can use the semicolon in the end, and we have to call this void function as well. So we will write o1 dot display, o1 dot display. Alright, we are done. Let's see whether it works or not. Let's save it and check it. So as we can see, the result is -2, that is 6 minus 8 equals -2. That is correct. And n1 is -6 and n2 is -8 because we have made them negative inside this operator function. We forgot to add some space in n2 and n1, so that is why it is looking like this. But the answer is correct, and this is how we can do the operator overloading. In this part we have used the return type, then the operator keyword, then the symbol, and if there are any arguments then we can pass those arguments, and if there are not, we can put it like this. So this is our example of operator overloading. Let's do another example. So now we'll do an example of function overriding. So let's name this poly3.cpp. So in function overriding, the function of base class gets a new definition in the child class, and when we call the function of the child class using the object of child class, then the function of base class gets overridden. So now let's do the example of this function overriding. I think we have named it wrong. poly3.cpp. Alright, let's name it 4. poly4.cpp. Alright, now let's save it. Now include the header files. Using namespace standard. Now we'll start with the class parent. So this is the base class and we have named it parent. Inside the parent class we will create a function. For that we'll create the public scope. Inside the public scope we will create the function print, and we will display the message. This is the function of parent class or base class whatsoever. Alright, so this is class parent and semicolon in the end of the class. Now we'll create the child class, child derived from parent class. Name of the class is parent. Similarly we'll do the public scope and create the function void print. So it is same function as that of the above class, and inside this function we will display this is the function of child class, derived class, let's say. Alright, once we are done with this, semicolon in the end and semicolon in the end of the class as well. Then we can create a main function, and inside the main function we will create the object of child class, child obj. So as we have created the object of child class or derived class, so with the help of this we will override the function of the base class. So we'll write obj dot print, which is the name of the function. So as we have created the object of child class, so it will call the derived class or child class function, and in the end let's say return 0. Now save it and try to run this. This is the function of derived class. So as we have expected, so it is calling the child class function. So this function of the parent class gets overridden as we have used the object of child class and call this function print, which is of same name. So this function which is in the child class gets to print. derived class. So this is our output. So now let's do an example of virtual function in C++. Virtual functions are defined in the base class to ensure that the functions gets overridden, and when we use the base class pointer to hold the derived class object or the child class object, the base class pointer will always call the base version of the function and not the derived version. So to solve this problem, we use the virtual keyword in C++. So now let's start with it. First of all, we'll write hash include iostream. Now the namespace standard. Now we will create the base class base, and then we'll use the public scope. Inside the public scope we will create the virtual function. Use the virtual, the return type, then the name of the function, that is print. And we have created this virtual function inside the base class. Now we'll print. This is the function inside the base class as we have done previously in the previous question. This function, this is the function of base class. Yeah, it would be right. Alright, once we are done with this, we'll close the class by using semicolon. Now we'll create the derived class and we'll name it derived from the base class, whose name is base itself. Now here we will use the public scope and we'll create the function of derived class, print function, and we'll print this is the function of derived class. Alright, now we'll use the semicolon to end the class. Now inside the int function, int main function, first of all we will create the pointer of base class, base dereference operator b. So we have created the pointer of base class. Now we will create the object of derived class, derived d. So now we will store the address of derived class object to the pointer of base class. So let's do that. B, which is a pointer of base class, address of operator, the object of derived class. So now we will call the print function using the pointer of base class, and it will print the derived class function because the pointer of base class which we are using to call the functions points to the derived class object. So now let's do the calling part. All we need to do is the pointer and the arrow operator and the name of the function, that is print. After that we can write return 0. Now everything is done. Let's save this and run it. As we can see, this is the function of derived class. Here we can see, so the derived class function is getting called, which we wanted. So this is an example of virtual function in C++. We have used this virtual keyword over here, and using the base class pointer we have called this function, and these were some examples of different topics in polymorphism in C++. You can try some more examples on these topics. It will help you in understanding this topic in a better way. Header files allows us to assemble all the predefined functions in one place, and it is helpful because it is easier to gather the declarations in one place and then use them whenever we need them. And as all the declarations are gathered in one place, so it automatically reduces the complexity and it also decreases the number of lines of code. There are many functionalities of header files. One of them is it helps in taking the input from the user and also helps in displaying the output in a program. Now, let's learn what actually a C++ header file is. Header files are the set of libraries that contains predefined functions at a common place. So it basically stores the declarations at one common place and they are being used while writing a program. These header files usually have a .h extension and we use #include before writing the header file to inform the preprocessor that we are including this header file. Now let's discuss types of header files. There are two types of files in C++. First is predefined header file. These files are already present in C++ compiler. We simply need to import these header files using #include, which will inform the compiler about the header file, and then we can write the name of the header file between the angle brackets. Next is user-defined header file. These header files are defined or created by users. In C++, user can create their own header file and include it in the C++ library, and it can be used whenever it is required. Now let's learn how to create this header file. In order to create your own header file, first of all we will write the C++ code which we want to use whenever we want. After that we will save the file with .h extension. As we can see in step 1, we have written the code of two integers that are getting multiplied, and now we will include this in the program. To include this in the program, we will use #include, and after that we will write the name of the header file inside the angle brackets with the .h extension. Here #include will inform the compiler that a header file is added. And now as we can see in step 2, after the declaration of two integers we are calling the function product and passing the arguments x and y. After running this program we will get the output as 45. Because 9 into 5 equals 45 and we don't need to worry about writing the logic of it because we have already included this header file. Now let's have a look at some examples of header files. #include IOStream. IOStream is the header file that is used to read and write the standard input-output streams. Because of this header file we can take the input and display the output. And in case of IOStream, .h is not used because after standardization of C++, IOStream became standard header whose function is now in std namespace. Unlike earlier when functions were defined in IOStream before standardization. Next is fstream. Fstream are associated with files. It is basically used to read the information from files and write the information in it. And next is iomanip. Iomanip is a library that is used in the manipulation of input and output statements. So these were some examples of header files.
A pointer can be defined as a variable that contains the address of another variable. It basically stores the memory address, which means it points to an address of a particular value. And like a regular variable, pointers have a data type also. Now coming to reference and dereference operators. Reference operator or address of operator is defined as that operator which is used to get the address of the variable. It can be easily obtained by preceding the name of the variable with an ampersand sign. Now, dereference operator. Dereference operator basically returns the content stored in the variable pointed by the specified pointer. For example, if we write *a, then it will return the value of variable pointed by a. Now, let's see how to declare and initialize a pointer. To declare a pointer, first of all, we will write the data type. After that, we will write the name of the variable with an asterisk sign. For example, int asterisk sign a, float asterisk b, char asterisk c. Suppose if we want to store the address into a pointer, then we will write int, that is the data type, then ptr, that is the name of the pointer, with an asterisk sign equals to a variable a with ampersand sign, which means ptr will contain the address of the variable a. Now moving to a pointer arithmetic. C++ allows us to perform addition and subtraction operations on pointers. A pointer is basically an address, that is, it's a numeric value. Therefore, operations like addition, subtraction can easily be done on pointers. There are four types of arithmetic operations that can be used in pointers. That is, increment operator, decrement operator, addition, and subtraction. Each time a pointer is incremented by 1, it points to the memory location of the next element. But if the pointer is an integer pointer, its value on ptr++ would increment by 4 bytes because of the size of int data type. For example, assume an integer pointer with current value of 10. Now after the increment, its value would be 14 instead of 11 because int is of 4 bytes. Now let's learn about pointers and functions. Like a normal variable has an address, similarly every function has an address also. And we can easily access the function using its reference or address, only if we know the address of the function. Function pointers are similar to that of normal pointers. When pointers are passed to the function, the address of actual arguments in the calling function is copied into the formal arguments of the called function. And this is the syntax for a declaration of function pointer. Here int is the return type, and parentheses around function pointer tells the compiler that it is a pointer to function. And after this, they are argument lists. Now, let's discuss pointers and arrays. Arrays and pointers are very closely related to each other, and both of them are objects. When an array gets declared, the compiler assigns a continuous block of memory so that all the elements of an array can be stored in the memory. And C++ treats the name of the array as a pointer that contains the address of first element, which is known as base address. So basically, array name is the base address of the array. And if we have to assign the address of first element of array in a variable x, then instead of writing x equal to ampersand array of 0, we can simply write the name of the array only. Now, moving to the last topic, that is array of pointers. Like in array, we can store similar type of elements. It is same in case of array of pointers. But the only difference is, instead of storing the elements, the address of similar type of element is stored. In other words, it stores the pointers which point to the similar data type. And this is the syntax. First is data type, then name of array with an asterisk sign, then in the brackets, it is the size of array. Now, let's do some examples in our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Here we will do one example of pointer to understand reference and dereference operator. We will print the values of variable and the address of that variable also, and it will give us an idea about reference and dereference operator. Let's start. First of all, we'll make a new file and name this file as pointer1.cpp. So first of all, we will import the header file #include iostream. Now we will include namespace standard. After that, we'll make int main. And now we will declare a variable val and assign it a value, let's say 105. Now we will declare a pointer variable ptr. Now we will store the address of the variable val into the pointer variable. So we will write ptr equals ampersand val. Now we'll display a message. Before printing val variable, we'll display a message saying value of val is. Now let's see what is the value of ptr. For that we will have to print ptr also, and we'll write value of ptr is. Now we will print the pointer variable ptr also. Although the value of val and ptr would be same, but in order to check we will print that also. So we'll write cout value of specific ptr is. Now as we have printed variable val, ptr and asterisk ptr, so now let's check all these values. Let's first of all we'll write return 0. Now let's check all these values. Here we can see value of variable val is 105 and the value of ptr is this. This is actually the address, and the value of pointer variable ptr is 105. As we know that the value of val and the pointer variable is same because we have assigned this value, the address of variable val, to ptr, and then the dereference operator, as we know, returns the actual content of the variable. So that is why the value of variable val gets printed when we print the pointer variable ptr. And the address over here is the address of the val variable which we are assigning to the ptr. So that is why this address is getting printed. Now we'll do another example. Let's name it pointer2.cpp. Now we'll include the header files. Hash include iostream. After that, using namespace standard. So here we have an example of arithmetic operations in C++. So first of all, we'll write int main. Now here we will take 4 variables and 2 pointers. So let's do it. Int num1, num2, int sum equals 0, and int sub equals 0. We'll initialize it with 0. Now we will declare the pointers ptr1, ptr2. So let's take input of the required variables num1 and num2, and after that we'll do some arithmetic operations on them. So let's just write. First we'll display a message. Enter 2 numbers. Enter 2 numbers. Now we'll take the input. After this, we will store the address of num1 and num2 into ptr1 and ptr2 respectively. So let's do it. ptr1 ampersand num1, ptr2 ampersand num2. Now we will increment pointer ptr1 and ptr2. We'll do in a bracket, and we'll use dereference operator also. ptr1 plus plus dereference operator ptr2 plus plus. Here we are using dereference operator because we want to increment the value only. And as we can see, we have used increment operator. So by incrementing ptr1 and ptr2, the values of num1 and num2 will increment, and after that we will print those values. So let's do it. Before printing, we'll just print a message after increment. Now we will print ptr1 and line. Now ptr2. Now we will do the sum of these incremented values. So we will write sum equals dereference operator ptr1 plus dereference operator ptr2. Now we will simply print it. We'll write addition and we'll print some variable which we have already initialized as 0 earlier, and we'll write end line. So this will give us the sum of the incremented values of num1 and num2. Now let's talk about decrementing the value of pointers using decrement operator. Here by using this operator, the value of the ptr1 and ptr2 gets decremented. So let's start. We'll write decrement ptr1 minus minus. That is the decrement operator. Now ptr2 minus minus. Now we will write after decrement the values of ptr1 and ptr2. So we'll display a message saying after decrement now we will print ptr1 and ptr2. This will display the values of ptr1 and ptr2 after decrement. And at last we will find the subtraction of 2. So we'll write sub decrement operator ptr1 minus decrement operator ptr2 and cout will display first subtraction. We'll write subtraction, then we'll write the variable sub. Let's see how it. Before that, I think we forgot to mention the dereference operator while printing. We have to mention this because we want to print the values. Dereference operator. And let's put some space over here. Now let's try. Enter two numbers. So let's say we'll enter 4 and 5. As we can see, we have entered 4 and 5. After increment, it becomes 5 and 6. And on addition, it becomes 11. After decrement, it becomes 4 and 5 again. Then 4 minus 5, that is equal to minus 1. So this is the right answer. And this is how it's done. This was the basic example of arithmetic operations in pointers. Now let's do another example. Name this file as pointer3.cpp. Now we will include the header files hash include IOStream using namespace standard. Now we'll write int main. Now we will do an example of pointer and arrays in which all we have to do is to print an array with the help of pointers. So let's start. First of all, we'll declare a pointer. Now we'll declare an array named RRAY. And let's add some elements inside it. 5, 17, 20, 7, 9, 4, 6. I think these are 7 elements. Now we will assign array ARR to pointer PTR. So we'll write PTR equals ARR. After that, we'll run a loop from I equal to 0 to I less than 7 because we want to iterate array elements. So let's write for loop int I equals 0, I less than 7, I plus plus. Now we will display using dereference operator with pointer. Because we want to display the values, that is why we have used dereference operator. Now we'll do ptr plus plus. We have used ptr plus plus because we want the pointer to move to the next position after each iteration, and endl will help to print the output in the next line after each iteration. So after this, we'll write return 0. And let's try to run it. I think there is some error. Yeah, namespace. Now let's again try to run it. Instead of array we have used ARR. Hope it works now. Here it is. 27946. 5, 17, 27, 946. So these are our array elements which we want to print. So this is how we can print the array elements with the help of pointer. So these were some basic examples of pointers in C++.
So our first topic is, what is this pointer? In C++, this is a keyword that is used to represent an object that invokes the member functions. It automatically points to the object for which the object is being called. Or, in other words, this keyword points to the current instance or object of the class. For example, let us suppose we have a local variable of same name as that of the data member, and we want to assign the value of a local variable to the data member, but having the same name would create a problem. So in this type of case, we use this pointer. This keyword tells the compiler that we are referring to object's data members. Now let's learn about the syntax of this pointer. The syntax for referring class variable or instance variable would be this keyword, then arrow operator with class variable equal to local variable value. And the syntax for referring to current object of class would be this with asterisk sign or dereference operator sign. Now let's understand working of this pointer. This keyword represents the address of current instance of the class. This pointer acts as an implicit parameter to all the member functions. Now implicit parameters are similar to normal parameters. The only difference is these parameters are passed silently to the functions. That is, it is passed as a hidden argument and is automatically passed to the member function when it is called. Now let's learn how to access the executing object. As we can see in the example, we have created an object obj of class O, and with the help of this object we have called this function display, in which we are printing the address of the object, and we are also printing this pointer, and this is the executing object. So by printing this, we will get the address of object in the memory. Along with this, we can also access the data members using this keyword. Alright, now let's move to features of this pointer. The first feature would be to distinguish the data members from local variables, which means it helps in making the class members more readable by differentiating the members of the class and the parameters which have the same name. This keyword helps in differentiating between the class variable and the parameters. As we can see in the example, we are assigning the var variable, which is a parameter, to the class member var, and this can only be done with the help of this pointer. Now let's move to the next feature, that is method chaining in C++. Method chaining in C++ is a very useful feature of this pointer. It helps to chain methods together for ease and cleaner code. In this, each method returns an object and allows the call to be chained together into a single statement. It helps in invoking multiple methods that are chained together. As we can see in the example, set method, replace method, and inc method are chained together in a single statement, and arguments are also passed. So now let's go ahead and do some examples of this pointer in our code editor, that is VS Code. Alright, so here we will do an example of this pointer in which we will show that how this pointer differentiates between the class member and the parameters having the same name. So let's go ahead and first of all let's create a new file and let's name it this one.cpp. Alright, now we can write the header files #include iostream. Now we'll write the namespace standard. Now we'll start with the main function. We'll write int main. Inside int main, first of all, we will write the class name and then the object of that class, let's say obj. Now let's write return 0 first of all, and now we can make some calls with this object, but before that let's create class. So alright, now we have to create a class which has the name A. As we know, the class name is A, we have already defined, and the name of the object is obj. So let's create class A, and inside that class we will, inside the private scope, we will declare some variables. Let's say int x, y, and z. So these three are the variables. Now I'm sorry, spelling is wrong, int z. So these three are the variables. Now inside the public scope we will create a function. Let's say the name of the function is set. So data type is void, name of the function is set, and from the main function we will call this set function. So all we need to do is we'll write the name of the object obj dot operators set, which is the name of the function, and we will pass the arguments, let's say 20, 54 and 65. These are random numbers. Now here we will write int x, int y, int z. As we can see, the parameters and the class members have the same name. So variables are of same name. So for that we know that we have to write this pointer. So we will write this x. So here this x is the parameter 1 and this x is the class variable. So this pointer differentiates between both of them. As the name is same, so this will help in differentiating. We'll do the same for y and we'll do same for x. This arrow operator z equals to z. So here we are assigning the values to these class members. Now after that we will display these values. So let's create another function. Let's say the name of the function is void print. Alright, so inside this function we'll simply display these variables. So we'll write x value is the small one x value is the variable x, and after that we will write and l. Right, y value is y and l. We'll do same for z. We can copy it and just paste it. It will save some time. Alright, as we have displayed or printed all of these three variables, so as the class ends, so we need to add the semicolon in the end. Now this print function, we need to call this one. So with obj object we will call this print function. Alright, so after calling this we have already added return 0. So let's save this one and try to run it. Alright, let's check. Here it is. X value is 20, y value is 54 and z value is 65. So arrow operator helped us in differentiating between the class members and the parameters. What if we don't use this? Let's have a look at that as well. If we do not use this pointer, then let's save it and let's try to run this. Let's check the output. As we can see, x value is 0, y value is 0, z value is 0. It is not correct. So this one is right and this is our output, correct output. Now let's do another example. So here we will do an example and see that this pointer can be used for calling the member function as well. So we'll do an example regarding that. So first of all, let's name this 2.cpp. Let's save it and we'll start with hash include iostream. Now the namespace standard. We'll start with int main. Inside int main we will name the class and create the object obj. Class name is king and the object name is obj. So from here we will call a function, let's say obj dot, let's say the name of the function is text. Here we are calling, and let's say return 0 after this. Now we have to create this class. So let's create this class king, and inside this class king, inside the public scope, we will declare the functions. First of all, we'll declare a function call, and now we will define a function that is text. So inside this text function, all we need to do is to print a message and call another function. So first of all, we will print a text or a message, let's say hello brother. So after that we'll write endl. Now we will call another, not cout. We will call this function call which we have declared and not defined yet. So we will write this arrow operator cal call. This is how you can call using this pointer, and here we are calling this call function. So we'll close the class using semicolon, and now inside the class scope, let's say void king scope resolution operator. This means that this function is of class king. So now we will print whatsoever we want. Let's say a is, will display a text, let's say a, and that's it. Then we'll do the same for B and C. Here we will print B, and now we will print C. Alright, now all we need to do, and everything is done, yeah, because we have created this function outside, so we don't have to use this semicolon. Now we can save this and we can try to run this. Here we can see hello brother and ABC. So this is what we want to print. Here we can see we have used this pointer to call this call function, and after printing this hello brother, A, B and C is getting printed, so this means this is the correct output. Now let's do another example. Let's make a new file and save this one. Let's name it this3.cpp. Alright, so here now we will do an example of method chaining. As we know, we use method chaining when we want to return the reference of the object, and method chaining helps us in writing a clean code as it chains up the calling together into a single statement. So let's start. First of all, we'll include the header file hash include iostream. Now we'll write the namespace standard. Now we'll write the main function. By mistake we have. Alright. Now inside the main function, first of all we'll write the name of the class, that is test, and we'll create the object. The name of the object would be n1. Now we will chain up the calls. Let's say the name of the object n1, and the name of the function, let's say, is assign, and we are passing 100. And now we'll chain up display function with it. So this is method chaining. Now we'll write return 0, and now we'll start with the class. So class name is test, and inside the class we'll declare a variable, let's say num, and now under public scope we will write the function, and we'll not define the function in a usual way. We'll write the data type. First of all, let's say test is the data type, address of operator, assign, which is the name of the function, and argument would be num. The parameter would be num, and inside this function we'll use this arrow operator, and now we will assign the value of parameter num to the class variable. After that we can return reference to the object. We'll use the dereference operator and this pointer. Now we'll make another function, that is display, and inside this display function we'll print a message, and we'll print the variable, that is num. So first of all we'll print the message saying that the value of num is alright. After the class we'll put a semicolon, and we'll try to run this one after saving it. So as we can see, the value of num is 100. So let's do some modifications in that. Let's say we want to add 1000, so it will get added, but we need to save it first. Now we'll try to run. As you can see, the value of num is now 1100. So these are chain function calls, and when the reference is returned, this reference is returned, then this reference can be used to chain the function calls from a single object, that is n1 in this case. So this is the data type and this is the address of operator. When we are doing the method chain, we must do it like this, and then we will return the reference to the object. So these were some examples of this pointer in C++. You can try some more examples if you want to learn this topic in a much better way. So first is, what are references in C++? A reference can be defined as an alternative name of the variable. As the name suggests, it is used to refer to an existing variable. It is basically used to store the reference of the variable and is stored using an ampersand sign. Although the reference and address are the same thing, but their context is different. When we are talking about reference variable, then we will call it reference rather than address. The variable can either be accessed with the help of variable name or by the reference name. So as we have understood about references in C++, so now let's learn how to create reference in C++. Let's suppose we have a variable named data, and we know how to declare a variable. First its data type, then the variable name, and then we will assign the value to the variable. Here int is the data type, data is the variable name, and 10 is the value that is assigned to the variable. If we want to declare a reference variable for the variable data, then it would be like this. First is the data type with ampersand sign, then the name of the reference variable equals to the variable name of which we are storing the reference of. As you can see, int ampersand ref, which is the name of the reference variable, equals to data, which is the name of the variable. So we can say ref is the reference variable for the data variable and it can be used instead of the variable name. Now coming to reference in the function. We can pass the reference to the function as a parameter. It is similar to passing the pointers to the function, but it is safer. While passing the reference to the function, the changes made inside the function will also be reflected outside, because after passing the reference to the function, the passed reference will access the actual argument. So the changes that are done to the parameter inside the function will affect the arguments. In addition, it is safer and provides a cleaner code. To pass the value as reference, all we need to do is to change the function parameter as reference type. As you can see in the calculation function, int %a. Now let's learn about returning the reference in C++. Similar to pointers, references can also be returned. While returning the reference, an implicit pointer is also returned. In return by reference, no local variable is returned and no constant is returned. Only the global variable is returned. In return by reference, function calling is done on the left hand side of the assignment operator. As you can see in the example, n is returned from the function, but it is not the value that we are returning, but the address of the variable. When this variable is returned, then the value 15 is assigned to it, which is then printed as we can see in the example. Now coming to applications of references in C++. So first is, references helps in modifying or changing the values inside the function without actually passing the actual arguments, because we can easily pass the reference instead of variable, and if we pass the reference to the function, then also it can modify or change the values. Second is, references helps with operator overloading, because unlike pointers, they work with references and values rather than pointer variables. Third is, references helps with writing less error-prone code, and by replacing values with references while calling avoids the unnecessary copy of data. So these were some applications of references in C++. Now let's understand the difference between reference and pointer. The reference can be defined as an alias of the variable. Here the word alias means additional name, or we can say also known for the name. On the other hand, a pointer is used to store the memory address of the variable. Reference cannot have a null value, whereas pointers can have a null value. References cannot be reassigned to other values, whereas pointers can be reassigned to other values. It returns the reference of the variable. On the other hand, pointer returns the value located at the address of the variable. Reference can be initialized during its creation only. It cannot be reinitialized, whereas pointer can be initialized as many times as required. So these were some differences between reference and pointer. Now let's go ahead and do some examples of reference in C++ in our code editor, that is VS Code. Alright, so here we will do an example of return by reference in C++. We all know how to return a value from a function. So now we will understand how can we return a reference from the function. Alright, so let's start. First of all, create a new folder and let's save it and name it as ref1.cpp. Now we will save it. Alright, so first of all we'll include the header files and then we'll start with the main function. Hash include iostream, then the namespace standard, now let's start with the main function. Inside the main function, first of all, like normally we'll do for the functions, we'll call, let's name the function as club. So this is how we normally call a function, and after that we create a function like this, like int club, and then This is how normal calling works, but in this case we want this function to return the reference, and for that we have to use the ampersand sign. So we have used this ampersand sign, and this is the syntax: int, which is the data type, then the ampersand sign, then the name of the function, and if we want to pass any arguments then we can do that. And keep in mind that inside this function we cannot return any local variable or any constant. Like we cannot create a variable inside this function, assign it some value and then return it. We can't do that, and we can only return the global variable. Let me show you that we cannot return this, return 8, as this is a constant, and we can't do like this, like int p equals to 9, and then we will return p. We can't do like this as well. All we need to do is to create a global variable and then we will return. Alright, so let's create a global variable. Let's say the global variable is n, and so we'll return n. Now if we want to assign some value to this global variable, we have to call this club function, and we have to make this calling on the left hand side of the assignment operator like this. And now we have to assign the value, like let's say the value is 75. So here we are assigning the value and calling this reference operator. We are assigning the value to this global variable, this n global variable, and in this part we are actually assigning this 75 value to this global variable n. Now we can print this n variable, which is global, and check if its value is 75 or not. Alright, so let's save it and let's try to run this. As you can see, 75. So this is an example of return by reference in C++. Now let's move on to another example. Alright, now we know a reference cannot be reassigned. That also means a single reference cannot refer to two different values. But two different references can have a single value, or in other words, a value can have two different references. So in this example, we'll show how a value can have two different references. So let's start doing this example. First of all, we'll include the header files, hash include iostream. Now the namespace standard. Alright, now inside the main function we will create a variable and two different references. The variable is num and we will assign it a value, let's say 70, and we will create two different references, int num1 n1, and we will assign it to num and n2, which is also assigning to the same variable. So there are two references, n1 and n2, which are referring to the same variable num. So now we will print this variable num and both of these reference variables, that is n1 and n2, to check if they are pointing to the same value. So let's do this. We will write cout value of num is alright. Now again, value of reference n1 is n1 and l. Similarly, value of reference N2 is N2 and L. Alright, so we have printed all of these variables and references, and now return 0, and let's check if they are running fine or not. As you can see, value of num is 70, value of reference n1 is 70, and n2 reference is 70. So we can say all of these references and variables are pointing to the same value, and the value of num can also be accessed by this reference variable n1 and n2. Alright, now let's do another example. Let's name it ref2.cpp. So here we will do an example of references in C++ in which we will pass the reference into the function to swap the actual values. Basically, we don't pass the actual arguments, we only pass the references and swap the values. So let's start. So let's include the header files. Now we will create the main function, and inside the main function we will declare two variables and assign the values. Int y 17, let's say. Now we'll print, first of all we'll print before swapping, right? Alright, so now we will call the function swap. We will create a function swap afterwards, and we'll pass not the values but the references, and then we can similarly copy this one and just paste it again, and we'll do that after swapping. Here we have to do before swapping, right? So first of all we'll print the value of x and y before swapping, then we will print the values of x and y after swapping. So now we have to create the definition or write the definition of swap function. So let's write void swap, and do remember that here we are passing the references, not the values, so we have to write like this: int ampersand n1. This is how, when we are passing the values, we have to write like this, and int ampersand n2. Here this n1 is referring to x and this n2 is referring to y, and inside this swap function we'll simply swap as we know how to swap. Int temp equals n1, then we'll do n1 equals n2. We all know how to swap. Here we haven't passed the values, actually we have passed the reference, and using those references we are swapping the values. So now let's try to run this, save it, and let's run this. As you can see, before swapping x value is 12 and y value was 17, after swapping 17 and 12. So as we can see clearly that the value is swapped. So we can say using the references or by passing the references to a function, we can actually swap the values. So this also proves that references can access the values. So these were some examples of references in C++. References in C++ is a very simple topic, and there are very limited examples on this topic. And if you find some more examples, please do try them. Starting with the first question, that is, what is the difference between C and C++? Now C language is a procedure-oriented language, whereas C++ is partially object-oriented language because it doesn't support object-oriented features completely. C language supports top-down approach and C++ supports a bottom-up approach. Here the bottom-up approach means the development of modules in C++ starts from the bottom. C doesn't support function or operator overloading, whereas C++ supports both function and operator overloading. C language doesn't support virtual and friend function. C++ language supports both virtual and friend function. C language has 32 keywords, whereas C++ has 52 keywords. Next question is, what are classes and objects in C++? A class is a user-defined data type that contains data members and member functions. It is defined with keyword class. Objects are defined as an instance of a class. Once the object is created, then it can operate on both data members and member functions. Coming to the third question, that is, what are access modifiers? Access modifiers are used to define accessibility for the class members. It defines how the members of the class are accessed outside the class scope. There are three types of access modifiers, that is private, public, and protected. Let's start with private. The members who are declared as private cannot be accessed directly from outside the class. They can only be accessed by the member functions inside the class. Now public. The members who are declared as public can be accessed from within the class as well as outside the class, and even from outside the package as well. Now protected. The members who are declared as protected can be accessed from within the class and from the derived class. Now coming to the next question, that is, what is C++ OOPS concept? OOPS stands for Object Oriented Programming. There are some concepts of OOPS, that is, object, class, inheritance, polymorphism, encapsulation, and abstraction. Now let's understand these concepts. Let's start with object. An object is a basic unit of object-oriented programming. It can be defined as an instance of a class. We can create multiple objects of a class. Now class is a template of an object. It is user-defined, which holds member functions and data members. The data and code which is defined inside the class are said to be the members of the class. Now inheritance. Inheritance can be defined as a process in which child class inherits all the properties and behavior of its parent class. The class which is inherited is called the base class, and the class which inherits is called the derived class. Now polymorphism. Polymorphism is the ability to give different meanings to the same function. It allows us to redefine a function and create it with a completely new definition. Now encapsulation. Encapsulation means binding code and data together into a single unit. Now abstraction. Data abstraction specifies hiding the internal details for the simplicity and showing the functionality to the user. Now coming to the next question, that is, what is the difference between a while loop and a do-while loop? So first is while loop. While loop verifies the condition. If it's true, then it iterates the loop till the condition becomes false. On the other side, do-while loop first iterates the loop body once, then it checks for the condition. In while loop, the syntax is while keyword, then condition inside the brackets. The syntax of do-while loop is do block, and after that while keyword with a condition. In the while loop, if the condition is false, then not a single statement will execute inside the loop. On the other hand, in do while loop, if the condition is false, then also the body will execute once. Now, coming to the sixth question, that is, what is a constructor? A constructor can be defined as a member function that is invoked whenever we create an object. It has the same name as that of class. There are two types of constructors in C++, that is, default constructor and parameterized constructor. Default constructor are those constructors which do not take any parameters. If we don't define any constructor, then the compiler will automatically provide a default constructor. On the other hand, parameterized constructor are those constructors in which we can pass the arguments. Now, coming to the next question, which of the following operator cannot be overloaded? Our options are A. Subtraction operator, B. Addition operator, C. Ternary operator, and D. Modulo operator. So our correct answer is C. Ternary operator, because overloading this operator is not syntactically possible. So let's move on to our next question. Write a program to find the factorial of a number. So here we have to write a program of factorial in which we will enter a number and its factorial is displayed on the screen. So here we have declared an integer n, which we will take an input from the user, and another variable fact which we have initialized as 1. After that, we have displayed a message, enter a positive integer, and we have taken an input of the integer. Now if the number or integer entered by user is less than 0, that is in the negative, then it will display error as there is no factorial of negative number, and all the positive number will go to the else block. Inside the else block we have used for loop, and it is iterating from 1 to n, that is the number users had entered. And inside the for loop it is written fact into equal to I, which can also be written as fact equal to fact into I, which means one by one all the numbers from 1 to n will be multiplied by fact variable, and the result will be stored in the fact variable itself. Once the iteration is done, then the fact variable where the result is stored is displayed. So this is the factorial program. Now coming to the ninth question, that is, what is operator overloading? Operator overloading is a mechanism in which we provide an additional meaning to the operators. In this, an operator is overloaded to give user-defined meaning. For example, we can overload an addition operator in a class like string to concatenate two strings by only using addition sign. Now, our next question is, what if we compile a program without the main function? Now, another question arises, is it possible to compile a program without the main function? So the answer is, yes, we can compile a program without the main function, but we cannot run or execute the program because the main function is the entry point from where all the execution begins, and without the entry point, the program is not executable. So we can compile the program, but we cannot run it without the main function. Now, moving to the next question. What is operator overloading and function overloading? As we have already discussed operator overloading allows operators to have an extended meaning apart from their predefined meaning. Function overloading, on the other hand, defines a method in such a way that there are multiple ways to call them. Now, our next question is, what is the difference between equal to operator and assignment operator? The equal to operator checks whether two values are equal or not, If equal, then it's true, otherwise it will return false. The assignment operator, on the other hand, assigns the value of right variable to the left variable. Coming to the 13th question, that is, when void return type is used. Void return type is used when we don't want to return any value. It specifies that the function doesn't return a value. Function with void return type completes its task and then returns the control to the caller. So our next question is, what is call by value and call by reference in C++? First of all, both of these methods, that is call by value and call by reference, are the methods to pass the values to the functions. So let's start with the first method, that is call by value method. In call by value method, we pass the copies of actual parameters to the function's formal parameters. This means if there is any change in the values inside the function, then that change will not affect the actual values. In call by reference method, the reference or address of actual parameters is sent to the function's formal parameters. This means any change in the values inside the function will be reflected in the actual values, because here we are sending the address of the values. Coming to the 15th question, that is, what is inline function? The inline function is expanded inline when it's called. When this function is called, the whole code of inline function gets inserted or substituted at the inline function call. Or in other words, the compiler replaces the function calling location with the definition of the inline function at compile time. Its syntax is the inline keyword, return type and function name, and parameters inside the brackets. Coming to the next question, that is, what are pointers in C++? Pointers are the variables that holds the memory address of another variable. The type of variable must correspond with the type of pointer. For example, the pointer of character type can hold the address of character type variable, and the same goes for integer and other data types. Its syntax is type of variable and asterisk sign with the name of pointer. Moving to the next question, that is, what is scope resolution operator? A scope resolution operator is represented as shown. This operator is used to associate function definition to a particular class. This operator is used for the following purposes: to access a global variable when we have a local variable with same name. Second is to define a function outside the class. Now moving to the next question, and this question is output based question. So the question is, what is the output of the following C++ program? So in this question we have to determine the output of the following program, and we have to select the correct answer from the following options. So in this program, as we can see, two variables I and X are initialized as 0, and after that do block is there, and we know that do block executes for once regardless of any condition. And inside the do block there is if statement, in which the condition is if I mod equal to 0, then only the block will execute. So if I is initially 0 and we know 0 mod 5 is 0, so the condition is satisfied and it will display 0 as the value of X. X is 0 initially. After that the value is incremented for both I and X. Now the value of I is 1 and 1 mod 5 is 1, so it doesn't satisfy the condition. So the value of I will increment again, and similarly the process will repeat for 2 mod 5, 3 mod 5, 4 mod 5, but 5 mod 5 is 0. So the value of X here, which is 1, now will be displayed and increments to 2. Then afterwards I becomes 6, then 7, then 8, then 9 on incrementing, but doesn't meet the condition at that time. But when it becomes 10, the control will move outside the loop and 2 will be displayed. So our answer becomes 0, 1 and 2. So this is our answer 0, 1, 2. Now let's move on to the next question. So this question is a multiple choice question, and in this question we have to determine the size of integer data type. So our options are 4 bytes, 1 byte, 8 bytes and 2 bytes. So our answer is 4 bytes. 4 bytes is the size of integer data type. So now let's move to the next question. This question is, what is std in C++? First option is std is standard class in C++. Std is standard file reading header in C++. Std is a standard header file. Then last option is std is standard namespace in C++. So our correct answer is std is a standard namespace in C++. It is used in programs while writing using namespace standards, and it tells the compiler to take everything in standard namespace. So let's move on to the next question. So in this question we have to tell how to input a string in C++ with spaces. Now we all know how to input a string in C++ without spaces because it's quite easy. But let's understand how to do it with spaces. So in this question, as we can see, there is a string that we have declared S. The name of the string is S. After that we have displayed a message, enter the sentence with spaces. And then we are taking the input. Here getLine is the member function of iStream class, which is used to read the string with spaces. So as we can see, getLine, after that in the bracket cin, which is used to take the input, after that the name of the string, that is S, and after that we have displayed the string name, that is S. So this is how we can take the input from the user with spaces using this getLine function. So let's move to our next question, that is, what is the difference between new and malloc? Now both of these are used to allocate memory. So let's start with new. New is an operator, whereas malloc is a function. The new operator calls the constructor. On the other hand, malloc function doesn't call the constructor. In case of new, there is no need to specify memory size while using new operator. In case of malloc, we have to specify the memory size in malloc function. New operator can be overloaded, whereas malloc function can never be overloaded. Now next question is, what is the difference between prefix and postfix? In prefix, first the value is incremented and then the value is assigned to the expression. But in case of postfix, the value is assigned to the expression and then the variable's value is incremented. Now coming to the next question, that is, what is the output of the below C++ program? So as we can see the program, this is the program of enumeration. As we can see the enum keyword. So here 3 enum variables are there, that is blue, green and great. And we know that there are some default values that are assigned to the enum variables that starts from 0. But we also know that we can change these default values. So as you can see in this question, green equals 5. So green's value is 5. And we can see the element great has no value. So in enum, if this case arises, then the value of the next element would be 1 greater than its previous element. So ultimately the value of great element would be 6. So as you can see, here we have printed blue and great. So our output would be 0 and 6. That means the value of blue is 0 and the value of great is 6. So now let's move on to the next question. In this question we have to find the frequency of a number in C++. So as you can see in the program, we have given this number 13324 22523, and we have to find the frequency of the number 2, that is k equals to 2. K is the number. So in this program, first of all, we'll pass both of these values to a function named frequency. Now inside that function, we have declared a counter variable c and initialized it with 0. Now after that, we have used while loop, and inside the while loop we have put the condition num greater than 0. Now it means the loop will execute till the value of num is greater than 0. Now after that, inside the while loop we have put an if statement condition, that is num mod 10 equals k. Now keep in mind that k is the number which we want to find the frequency of, that is 2. Now num mod 10, we know that any number when mod with 10 gives the last digit of that number. So one by one, all the digits of this num variable will be checked, starting from 3, then 2, then 5, then 2, then again 2, then 4, similarly goes on. So one by one, all of these digits will be checked with the value of k, that is 2. And if the digit matches with k, then that counter variable which we have initialized as 0 will increment. And after that, num equals to num divided by 10 will delete that last element so that the repetition of digits don't occur. So this is how we can find the frequency of a number in C++. So now let's move on to the next question. Which of the following statement is correct about the program given below? This is again an output based question. So let's have a look at the program. And these are its options: 7, 14, 0 and 1. So we have to select one out of it. So in this program we can see a variable x is declared and a pointer p is there. And we have assigned this value 7 to the variable x. After that, we are storing the memory location of x to this pointer p. And at last we are displaying the output using the dereference operator, as we know that if we want to display the value at an address, then we use dereference operator. So our output would be 7, as the value at that memory location is 7. Now let's move on to the next question. Which of the following statement is correct about the program given below? Now in this question, again we have to determine the output. So let's have a look at the program. As we can see, there are 3 variables x, y and z, and we have initialized them 2, 4 and 5 respectively. And after that we are calling a function duplicate and we are passing the values. But in this case we are passing the values as reference. So this is the case of call by reference. And we know in case of call by reference, the actual value of the variable also changes. So here in this question we are passing the values as reference to this function named duplicate. Now inside this function we can see that every variable, each of these 3 variables is getting multiplied by 2. So in case of call by value, there will be no change in the actual value. But here we are not passing the arguments as call by value, but we are passing it as call by reference. So the changes will be reflected in the actual value. So when 2 is multiplied by 2, it gives you 4. When 4 is multiplied by 2, it will give you 8. And when 5 multiplied by 2, it will give you 10. So its output would be 4, 8 and 10. Now let's move on to the next question. How to write a program to check if the number is palindrome or not. So palindrome is a number that remains the same when its digits are reversed. So here we have to write the program to check if the number is palindrome or not. So before moving forward, there are 2 things that you should keep in mind. That if a number is mod by 10, that is number mod 10, it will give the last digit of that particular number. For example, if there is a number 123, then 123 mod 10 will give you 3. And if we divide that number by 10, then that will remove the last digit. For example, 123 divided by 10 will give you 12 as an answer. So now let's have a look at this question. Inside the int main, there are variables like num, digit, reverse, and n. And after that there's a message saying enter a positive number. After that we are taking the input num, and we are storing that num variable inside another variable that is n. We'll talk about this later, why we are storing this to another variable n. Now there's a do block. Inside the do block we can see digit equals num mod 10. Now to understand this, let us take an example as, let us suppose the number to be 123. Now num is that number, and we know that 123 mod 10 equals to 3. That means the last digit of that number. So now digit is storing the last digit of that number. After that we can see reverse equals to reverse into 10 plus digit. Now we know that reverse we have initialized as 0. So reverse equal to 0 plus 3. Now reverse now becomes equal to 3. After that we can see in the next line num equals to num divided by 10. That means 123 divided by 10. And as we have already discussed, 123 divided by 10 will give you 12. Now this 12 will again go to num mod 10, and the value of digit now will become 2. Now this 2 will be added in the second line as we can see, and reverse is 3 as we know. Now 3 into 10 becomes 30 plus digit which is now 2, that becomes 32. And after that line num equals to num divided by 10 will remove that 2 from the 12. So now the value of num is 1. Now again the num will go to num mod 10. 1 mod 10 gives you 1. So now the value of digit is 1. And in the next line reverse value is now 32. So 32 into 10 becomes 320. After that we will add the value of digit, that is equal to 1. So it will become 320 plus 1, that will give you 321. So after that the condition of while loop terminates. And after that we can see the reverse of the number is REV, reverse, because the result is stored at this variable. Now I'll tell you why we have stored num into the variable n, because we don't want to make changes with the num variable, that is the user input. And here we have used if condition, and inside the if condition all we have written is if the value that is entered by the user is equal to the reverse of that particular value, then that number is a palindrome, else the number is not a palindrome. Now coming to the next question, which of the following will give the size of object or type? So the right answer is the size of operator gives the size of object or type. Now let's move on to the next question. Which of the following is not a member of class? So the answer is among the following, friend function is not the member of a class. Now let's move on to the 31st question. That is, what is STL? STL stands for Standard Template Library. It is a library container that provides generic classes and functions. STL components are containers, algorithms, iterators, and function objects. So next question is, what is a friend function? A friend function can be defined as a function that can access private, public, and protected member of the class. The friend function is declared using the friend keyword. This function is declared inside the class. Now, next is, what is a copy constructor? A copy constructor is a member function that initializes an object using another object within the same class. The constructor is of two types, default copy constructor, and user-defined copy constructor. Now let's move on to the next question. How does the strings are stored in the memory? Options are sequence, null, non-contiguous, contiguous. So the correct answer is the characters of strings are stored contiguously in the memory. Moving to the next question. What is inheritance? Inheritance is the mechanism in which we can create a new class, that is child class, from the existing class, that is parent class. This child class is also known as derived class, and the parent class is also called base class. And in the inheritance, child class inherits properties and behavior from its parent class. So our next question is, what is abstraction? Abstraction can be defined as a technique in which we only show the functionality to the user, that is the details that we want the user to see, and hiding the internal details or implementation details which is not necessary for a user to see. Now let's move on to our next question. What is the output of the below code? So here we can see they have used ternary operator in this question. So first of all, as we can see, there are three variables a, b and c, and 5 and 6 are the values of a and b that have been assigned to them. And at line 11 we can see a greater than b, question mark a colon b. So this is a ternary operator. Here a greater than b is the test expression. If this test expression is true, then the expression after the question mark, that is a, will be the answer, and if it is false, then the expression after colon, that is b, will be the answer. That means if a is greater than b, then a will be the answer, and if a is not greater than b, then b will be the answer. And as we can see, the value of a is 5 and the value of b is 6, so the test expression is false, so that means b will be the answer. So now the value of c is b, that is 6. So our correct answer is 6. Now let's move on to the next question. What among these is used to return the number of characters in the string? Option A is size, option B is length, C is both size and length, and option D is name. So the answer is both size and length will return the number of characters in the string. Now let's move to the 39th question. What is the output of the below code? As we can see in this code, the value of j is 10. Then the value of j is incremented. As you can see in the line 10, j++. So the value of j is incremented to 11. After that, j is added to 100. And at last, j is added to 999, which will give us the result as 1010. That is 1010. And this value is being assigned to I. So our answer is 1010. Now let's move to the next question, that is the last question. Pick the correct statement about string objects in C++. Option A is string objects must be terminated by a null character. Option B is string objects have a static size. Option C is string objects have a dynamic size. Option D is string objects use extra memory than required. So our correct answer is C. String objects have dynamic size. They are dynamic in nature, that is their size varies as their value changes. So they don't use any extra memory. So these were some important C++ interview questions. So this is our code editor. And now let's create a new file and let's start with it. So let's add some header files. Hash include iostream. Now we will add another header file, that is fstream, for file handling operations. Now hash include iomanip. So this header file is used for floating point values. So now we'll add the standard namespace. Now we'll write the main function. Now inside this main function we will create an object of a class. Our class name is management and the object name would be mobj. After that return 0. Now we have to create this class. So we'll write class management, and inside this class we will make a constructor because we have created the object of this class. So a constructor would be called, and inside that constructor we will call the function. So let's do that. First of all, we'll write the public scope. Now under this public scope we'll write management. So this is our constructor management, and inside this constructor we will call a function. Let's say the name of the function is main menu. Alright, so now the class ends, so we'll write the semicolon in the end. Now inside this function main menu we have to create a menu that will display on the screen, and also we have to use this function many times inside this program, so we have to declare this function globally. So we'll write void main menu. So this is the function prototype. Now after that we can create this function. So let's write void main menu, and now we'll declare some variables, lchoice, int schoice, and another variable, let's say back. Now we have to create a layout or a structure for a menu. So let's do that. /t airlines. You can write any name as of your choice. Now we will write main menu. We'll write /t. Now again we'll add some space or some lines. Let's add /t. Now we'll create a structure in which we'll ask the user to press a particular button to open a particular functionality, like press 1 to open the customer details, press 2 for flight registration, press 3 for ticket and charges. So let's do that. Now I'll copy paste. I'll copy this part and paste it over here. In second one we'll write press 2 for flight registration. So we are done with the layout. Now we'll take the input from the user. So let's do that. Now we'll write lChoice, the variable that we have declared. Now for all three of them, we'll make a separate classes. That is, for customer details, we'll make a detail class. For flight registration, we'll make a registration class. For ticket and charges, we'll make a ticket class. And to call the functions of these classes, we'll have to make the object of these classes. So let's do that. So we'll write details D. D is the object name. Registration R. R is the object name. Ticket is the class name. T is the object name. So we have created these objects D, R and T. Now we'll use a switch statement, a switch case statement, and now we'll write lChoice. Now inside the switch case, first of all we'll create a case 1. Now inside this case we'll have to call a function of detail class. So let's do that, but before that we'll write cout customers so that it looks nice. Now we'll call the function. Let's say the name of the function is information, and now we'll ask the user to press 1 to go back to the main menu. Like if the user wants to go back to the main menu after filling the details or something like that, then he or she can click on this 1 button. Alright, now we'll take the input back. This is the variable that we have declared. Now if back equals 1, then we'll call the main menu function. That is, the main menu will display. And also in else block we'll do the same. We'll call this function only, and here we'll write press any key to go back to main menu. Now here we'll do the break. Case 1 ends. Now we have to create a case 2. Case 2 is for flight registration, so we'll simply display a message and call the function. We'll write book a flight using this system. Alright, after that we'll use /n. and handle. Alright, now we'll call this function r.flights. R is the name of the object and flights is the name of the function that we will create afterwards. Now we'll write break. Now we'll have to create case 3. Now case 3 is for ticket collection. Now all we need to do is to display a message saying that get your ticket. Alright, now we'll use /n. Now we'll call the function. T is the object name, bill is the name of the function, let's say. Now we'll display a message saying that your ticket is printed. You can get it or you can collect it. Now we'll write press 1 to display your ticket. We'll take the input, and if back equals to 1, then inside if condition we'll call this function display. T is the object name, display is a function. Now after that we'll display a message, press 1 to go back to main menu or press any key to go back to main menu. So we'll write press any key to go back to main menu. Alright, now after that we'll take the input of this, and if back equals to 1, then we'll write main menu, that is we call this menu function, and in else we again we will call this menu function to display the menu. Right after this break to end the case, closing bracket, and now here is the starting bracket. Alright, so now we have to create a case 4. Inside case 4, first of all we'll display a message saying that see out thank you, because in case 4, as we can see, press 4 to exit. So if a user press 4, will display a message saying that it is /n/n and then again a /t. Now thank you message will be displayed. After that handle. Now we'll write break, and after that there would be a default case. Now in this default case a message would be displayed like invalid input or something like that, right? invalid input, please try again. Right after that we'll use /n and -l. Now to go back to main menu so that the user can try once again, so we'll call this function main menu. Now after that break. Now we have to create classes. Like first of all we have to create this detail class in which we are calling the information function. So this is the information function, and now let's create its class, that is class detail. So let's do it. Class details. Now in the public scope we will declare some variables, and static string name and let's say gender. Both of these would be string. And now after that let's create the variable phone number and gender, not gender, age. We have already created gender. Now age would be integer. Then there is address, we'll write add. Then there is another variable static int customer ID, so we'll write CID. Now an array we have to create. Let's give it 100. Now let's create this function information. So inside this information function, first of all we'll ask the user to enter the customer ID. So /n, enter the customer ID. After that, now the user will enter the customer ID CID, as you can see. Now we'll ask the user to enter the name. Then the name variable. Then we'll ask the user to enter the age. Then there is address. After that there would be gender. Now once the user has entered all these details, then we'll display a message saying that your details are saved with us. So we'll write your details are saved with us. Alright, so we have to end the class over here, so we'll use semicolon. Now we'll create another class. Now we will create the registration class, but before that we have to use some of the variables of the detail class in the ticket class. So for that we'll write int detail scope resolution operator CID. This is the variable that we want to use. Then the name variable, we'll write string name then that variable gender. So we'll write string Alright, so now we can create this class. So let's do this. Write class registration, and now inside this class, first of all, we'll declare some variables under the public scope. We'll declare a static variable choice, then another variable that is choice1, let's say, then another variable back, then a static float variable named charges. Alright, so these are the variables. Now we have to create the function flights that we have called from the main menu function. So this is the flight function. Now inside this flight function there is a character array named flight n. Now after that, inside this array we'll put the name of the countries as the elements. So let's start. First of all is Dubai. After that there is Canada. Then let's say another one is UK. Then there is USA. After that there would be Australia. Then let's say Europe. Alright, now using a for loop we will display each of these countries one by one. So we'll write int a equals 0, a less than 6, a plus plus. Now inside this for loop we'll write a plus 1 dot flight 2. So here what we are doing is this a plus 1, that is 0 plus 1, so Dubai will be displayed, then one by one Canada, UK, US, Australia, all of these will get displayed. And now after that we'll write flight n and L. Now all these countries will be displayed to the user. So now the user have to select a country. So first of all we'll write welcome to the airlines, then and L. After that we'll ask the user to press the number of the country of which you want to book the flight. So we'll write press the number So we'll take the input from the user, see in choice. Now after that we'll use switch statements. We'll write switch, inside we'll write choice, and now we'll make some cases. Case 1 will be of Dubai, case 2 will be of Canada, then UK, US, Australia, and then Europe. So let's start with Dubai. So we'll display a message we'll write welcome to Dubai Emirates. Alright, now /n. Now again we'll display a message saying that your comfort is our priority. Enjoy the journey. Now we'll display following are the flights. Following are the flights. Alright, so now we'll display first flight. So we'll write this is the name of the flight, and now and now we have to display also that the timing and the date of the flight and how many hours will it take and the price. So let's do that. So here we'll write /t, then we'll write the date, after that the timing, there is 10 hours flight, rupees 14,000 let's say. Similarly, let's copy and paste. Let's say there are 3 flights that are going to Dubai, and let's change the model numbers. 6:58 and the time and the date also. Alright, so these are the flights. Now we will ask the user to select the flight. Right, select the flight you want to book. See in choice 1. Now if the user chooses 1, then we have to create the condition. You can use the switch case or you can do if else as well. So let's start. If choice 1 equals 1, that is if the user or the customer chooses the first flight, then charges will assign the flight charges like 14,000 and display a message saying that you have successfully booked the flight. you can go back to menu and take the ticket. We'll display this message. So this is our if statement. Now we have to create else if statement as well. For the condition we'll write if choice 1 equals 2, then what we'll do is, let's just copy and paste to save time. We can copy this part and paste it over here. Charges, as we know, the charges of this flight is 10,000. So we'll write 10,000 and its number was 658. Alright, similarly for the third flight as well, we'll do the same. The charges was 9,000, so let's do that. The number was 498. We have to change this one. Let's say 508, so that the flight numbers are unique. Now in else block we'll write invalid input shifting to the previous menu. So we'll simply display that. And then we will call the flights function. After that, if the user wants to go back to the main menu, so we'll display a message for that. Press any key to go back to the main menu. If the user chooses 1, that is if back equals 1, then the main menu function would be called, and same otherwise. Similarly, we'll create case 2. So let's do that. In case 2, we'll just copy and paste this one to save some time. Alright, the changes we have to do is welcome to Canadian Airlines. And now your comfort is a priority. It's alright. Following are the flights. So the model number and number of flights we have to change. Let's say, and the timings, like, and the dates and time, it's 2 p.m. You can change that as per your choice. You can do whatsoever you want. "20 hours. Then select the flight you want to book. Then similarly, the first flight was of 34,000. CA198. And if you choose 2, then there would be 29,000. $40,000. The rest is all good. Shifting to the previous menu as we have done previously. And now again, after this else, we can create case 3. So inside this case 3, we'll write welcome to UK Airways. So we'll write so now let's say to UK there are only 2 flights. Let's say there are only 1 flight to UK. So we'll write UK and its flight number is 798, let's say, and the timings are, and date is first of all 12 and the timing is 10 AM and it will take around 14 hours and 44,000 rupees. Select the flight you want to book. This is same, and here I have to change 44,000. Alright, so to UK there is only 1 flight, so we not need to create these else if statements, so we can just cut it. And in else block the rest is same. So now after that we have to create case 4, and we can copy and paste this one as well. So our 4th flight was of US, that is US Airways. Alright, now we will change the name. We'll write US 567 and the dates, it's our choice. Assign it 39,000 here and there is 42,000. After this, now case 5 would be of Australian Airlines, so we'll write case 5 and copy paste this part, and here we'll write Australian Airlines. So let's change, we'll write AS and 698, timing, date would be 18/9 and 44,000. So alright, else everything is done in this part. Now we'll create case 6. In case 6, all we need to change is Welcome to Dubai Emirates, and we'll change it to European Airlines. European Airlines, then we'll change its name to EU 498 instead of 498, and the date, let's say 2, time is 2 AM, 18 hours of flight, and its price is 36,000. $31,000. 10 AM, and alright, now we have to change its model number as well. Alright, so EU 898, and its price is 36,000. Its price is 37,000. Alright, rest everything is done in this part. Now let's create the default case. Alright, in the default case we will write invalid input, please shifting to the main menu. And then we will call this main menu function. Now we'll write break and close the switch statements. Alright, so this registration function is done. It's pretty long, as we have created 6 cases of all the countries named Dubai, Canada, UK, US, Australia, Europe. Now only one function is or class is left, that is ticket class. So let's create this ticket class. Alright, so now after this registration class we'll have to use the semicolon. So now before this ticket class we need to know that we have to use some variables of registration class and the details class in this ticket class. So we will do the multiple inheritance, and before that let's do the same thing as we did earlier. Float registration, because we have to use these variables, so we'll write the class name, then scope resolution operator, charges is the variable, then another variable would be choice. Both of these variables is of registration class, so that is why we are doing this. Alright, now we will start with the class ticket. We'll write class ticket, then we have to inherit both of these classes, that is we have to use multiple inheritance, right? Public registration and then details. So here we are using the multiple inheritance because we have to use the variables of both of these classes in this class ticket. Now in the public scope, we'll start with the function that is bill, void bill. And now inside this function, first of all, we'll declare a variable named destination. And we'll left it like this because we have to assign it a choice that is being made by the person who wants to travel to the country. So now offstream, as we know, is used to create or write information in the files. The object of is offstream is outf we have created. Now let's say the file is records.txt. You can name it as per your choice, in which the data of the flights is being stored. Now we'll write inside this records.txt file. So as we know, to write inside the file the object name and then whatsoever we want to show inside the file, XYZ Airlines,
ticket,
details, that is class name, scope resolution operator, CID, then NL. Similarly, we'll do that for name and gender as well. Now when it comes to destination, as we have left the empty space, now the user, if the user will press 1, then it will go to Dubai. If 2, then Canada, 3, then UK, 4, then USA. So we'll have to do that as well. So we'll write if registration, as the class was registration, scope resolution operator, choice equals 1, then destination variable equals Dubai. And let's copy this part because we have to use else if statements as well. You can just copy and paste. All we need to do is else if. Now we can change it to choice 2 and name to Canada. Now after that we'll simply print or write the destination. So first of all we'll write destination and then we'll print the variable. Let's do /t to add some horizontal space. Now destination variable, alright, now we'll write the flight cost. Because it is a variable of registration class. Alright, now we have to close this object or file, outf.close. We have closed the file. Now we have to display the receipt as well. So for that we have to create another function. Within this class only we'll create void dispBill, that is display bill. So inside this function we will create an ifstream class and its variable, let's say, would be ifs. We all know it ifstream class is used to read from the file, so we are actually reading here. So we'll write records.txt file. Now we'll use the if condition inside this. So we'll write if not ifs, that if it doesn't exist then it should show an error, that is, let's say, file error. Now if the file is there, then we'll use while loop and we'll check not ifs dot end of file, that is, here we are checking the file till the end, that is every content of the file we'll check, and ifs dot get line array 100. Here we have used getLine to read the content from the file, and while loop will help us in doing that. After that we'll print array and then endl. Alright, after that we have to close this file as well. So we'll do that, ifs.close. Now we have to close the class as well, semicolon. So yeah, our code is pretty much done. After this there was main menu and the main function. So now let's try to run this one. Before that, let's save it and let's name it as flight.cpp. Alright, now let's try to run this. There are a few errors. Alright, so first error is this one, and let's check them all. Flight.cpp. line 66, there's some error. Alright, function name is wrong, flight, we missed the T. Then line 466, in line 466 where it is outf, we forgot to write f, we missed the f, and then 526. This one is associated with the previous one error, that is information error. Let's go to 561 t.display. Alright, so we wrote the wrong name. It was disp bill. Alright, now let's try to run this again. Semicolon, we forgot. Now as you can see, XYZ Airlines main menu. Press 1 to add the customer details. There's a little bit formatting error, you can figure it out yourself. Press 1 to add customer details, press 2 for flight registration, 3 for ticket and charges, and 4 to exit. So let's say a new customer I am, so I'll press 1 and I'll write customer ID 1. Now the name of the customer, let's say Raj. Age of the customer is 23 and address is Chandigarh. Alright, now gender is male. Now your details are saved with us. Alright, now press any key to go back to the main menu. We can press any key, 2, 3, 1. Then this is the main menu again. Now I want to register a flight. I'll press 2. So these are the flights: flight to Dubai, Canada, UK, USA. We forgot to add some space. We must add some space over here. So these are the flights to Dubai, Canada, UK, USA, Australia, Europe, and welcome to airlines. They are asking us to press the number of the country of which you want to book the flight. Let's say I want to go to USA. So 4. So these are the flights: US 567, US 658, US 508, and these are the timings and these are the dates. Let's say I want to go to 658, US 658, then I'll press 2. So there's a mistake by us, we forgot to change the name of this flight. We'll change this later. And now let's go back to the main menu. Now let's say we know that we have booked this US 658, but there was some writing error. We by mistake forgot to write US 658 over here. Instead we write TUB. Now as we know that we have this flight that is booked, so we want to go for ticket and charges, so we'll click on 3. Your ticket is printed, you can collect it. Alright, press 1 to display your ticket. As you can see, customer ID 1, customer name Raj, male, description destination USA, flight cost 39,000. As we know, this is the 39,000 flight. So this is how you can build this project. And now let's correct our mistake. Let's go to Australia, US flight, sorry. So here it is. Let's change it to US. And now let's save it. So now it will work fine. So this was our project on airline reservation system. You can also try this project on your own. Alright guys, with that we have come to the end of this session.
So guys, we have come to the end of our full course. If you have any doubts or questions, ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn. Hi there, if you like this video, subscribe to Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, you can check the description box below.